Hi everyone. In this particular session, we are going to discuss Gate DA, All India Mock Test 5 solutions. Okay, AIMT 5 solutions. So let's get started. Now let's see this question. This question was related to machine learning. So in this question, they are saying that you have some input feature X, which is n dimensional, and then you are asked to predict Y, where Y can be plus one or minus one. You have no knowledge of the distribution of X and Y. So which of the following methods are appropriate? Okay. So since you do not know the distribution of X and Y, like what is the pattern they are following, so that's why perceptron and linear regression will not be the good choice. Why? Because they are good only when you know that okay, the decision boundary would be the linear. I mean, you know that the distribution is such that if you are perceptron you can use for the regression also, but if you're using the perceptron, you it will give you the linear decision boundary. Similarly, for the linear regression also, right? So given any distribution, right? Given any distribution, k nearest neighbors is basically one of the unsupervised method. It could be good if you do not know anything about the distribution. So this could be good. And decision tree with unlimited depth. Unlimited depth means that you are not, very much particular that okay, or till depth 2, till depth 3 you will be using. Unlimited depth means it is up to you that till what depth you want to use, right? So basically, decision tree is also good choice. I mean, perceptron and linear regression won't be good choice because of the linear boundary. So that's why B and D are the correct answers here. Okay. Now let's go to the next question. In this question, they are saying that what is the method to determine this lambda? I mean, using which set you will be determining this lambda. So since lambda is called hyperparameter, right? It is called hyperparameter. Hyperparameter means a parameter. This is also a parameter which we do not, but we do not learn this parameter through the data. I mean through the training set. So that's why we call it hyperparameter, and we learn hyperparameters using the validation set, right? Either you can use k-fold cross validation or directly just the validation set, but we use a validation set to learn this lambda, so that minimizes the validation error. So that's why B is the correct answer. Now, in this question, they are just asking us to differentiate this fw is given here. So, if you differentiate this, it will be 1 upon 1 plus e power minus w transpose x, right? Now, multiplied by differentiation of this whole thing, right? Some of the students had made the mistake and they have just done the differentiation of this. But no, you have to multiply the differentiation of this whole thing. The differentiation of whole thing will be differentiation of 1 is 0, and then differentiation of this e power something will be the same, multiplied by differentiation of this w transpose x, right? So what is the differentiation of w transpose x with respect to w? It will be minus x, so you can say minus x. Okay, that's how you can differentiate this, which will equal to if you multiply e power w transpose x on both sides, I mean on numerator and denominator. So it will be 1, which will be equal to, you can say it will be 1 divided by e power w transpose x plus 1 and then minus x, right? Minus x. Okay. So this is the correct answer. And if you notice, the answer is given by A. Okay. Answer is given by A. So you can check that answer is A. Okay. So this multiplied with the differentiation of this only. Okay. The differentiation of this is coming out to be like this. So that's all, right? That's all. That was an easy question. Hope you were able to solve this question in the exam. Now let's see the next question. The next question is related to SVM. They are saying that SVM is soft margin and hard margin. You have two choices. It is given the data is separable. Okay, the data is linearly separable, and then we run both soft margin and hard margin. So suppose there are plus, okay, and there are minus. Okay, so it is very well linearly separable data, but still there could be multiple decision boundaries possible, which means hard margin, we know that hard margin will give you the decision boundary which is in between this, But soft margin has different objective function. In that case, you basically you also have plus c epsilon. I mean, there are some epsilons which is called slack. Okay, I mean, since the objective function is different, that is why the boundaries, it will also give you the solution, but the boundaries may not be exactly same. Okay, see, hard margin and soft margin are not same for linearly separable data. Okay, it's not like this hard margin is same as soft margin. Okay, it's not like this for linearly separable data, right? It's not like this. For example, um, let me give you one example here. See here, suppose there are like plus points. Okay, and these are the minus points, right? These are the minus points. Hard margin will say, let me give you the decision boundary here only. Okay, hard margin will say, this is the hard margin boundary, right? This is hard margin. So hard margin. But in case of soft margin, it will say that, okay, let me just ignore. Okay, let me just ignore this one or 2 points. Let me give the margin probably something like this. Okay, soft margin will probably give you something like this, right? Because it can tolerate the slacks. Are you getting my point? So hard margin and soft margin are not same for the linearly separable data. This data is very well linearly separable. Still hard margin is giving you this boundary, but soft margin is giving you this boundary. Okay, and there are actually two different objective functions. Okay, so soft margin and hard margin is same. We have seen this when c is infinity. Okay, when when c tends to infinity in soft margin in that case it is equal to hard margin, which means now we are not able to tolerate any slack. Okay, the c tends to infinity means now we cannot tolerate any slack. Okay, so it means now we cannot tolerate any slack. Understood? Okay, so basically here in this case you can say that can be different in two cases, but the boundaries are same. No, W and V can be different and one can be. I think C is the correct answer. Okay. Now let's see this question. In this question, they are just asking us to differentiate this function with respect to h. So let's just quickly do it. So basically, they are saying that by mean or by var is basically something like this. And now we want to differentiate this function. It will be 1 upon n summation over alpha yi minus h whole square plus lambda h, right? This is 1 upon n. Now, if you try to differentiate, then you will be getting something like this. 1 upon n is as it is, summation will be as it is, and then 2 into alpha yi minus h, and then with respect to h also you have to do it. I mean this particular quantity which is minus 1. Okay, so minus 1 means you can multiply by minus 1, or let me write like this way. Okay, let me write h minus alpha yi. Okay, and then plus I think here it will be just lambda. Okay, now we want to know the value of h, which you can find out by just a simple things. So let me just transfer a few things here and there. So it will be, I think, this is 1 upon n, right? So what you can do, you can put the equal to 0 is there. So let me go to the next page and let me try to solve this equation. I want to find out the value of h. So from here you can say this is 2 will be here. So basically equal to minus lambda by 2. I mean this 2 you can transfer here, and then lambda you can transfer here. So here it will be just remaining 1 upon n summation over h minus alpha yi, right? This will be remaining. And now what you can do, you can just further expand this. This is summation over uh, see this is basically something like this. I mean, you can just expand the summation alpha yi divided by n equal to minus lambda by 2, right? This is just h because this is nh divided by n, so this is just h. So what you can do, you can write like this. You can say this is just h minus this is alpha, this is y bar. It is already given. I mean, the notation are already given here that this is y bar. Okay, this is y bar, and with the n divided by n, alpha y bar equal to minus lambda by 2, right? From here, if you find out h, it will be minus lambda by 2, and then alpha y bar minus lambda by 2. I think B is the correct answer, right? B is the correct answer. Alpha y bar minus lambda by 2. So it was also easy question. Just a bit of differentiation was needed. Okay. Now let's solve this question. In this question, they're just asking the probability of x equal to 0. Probability of x equal to 0 will be just, I think, k into 1 plus 0 square, which is just k, right? So the answer will be k, but obviously they're asking in the numerical values, not in terms of the k. So let's just find out the value of k, right? The value of k will be basically, you can sum all the probabilities and then you can find out the value of k, right? So value of k will be basically probability of x minus 2 minus 1 0 1 2. You can sum all these probabilities, right? But one thing you notice here, since it is mod x, so minus 2 minus 1 probabilities are same as 1 and 2. Okay, so basically probability of let me write x minus 2, it will be k into 1 plus 2 whole square. This is the probability of minus 2, plus probability of minus 1 will be k into 1 plus 1 whole square, plus probability of 0 will be k into 1 plus 0 whole square. Okay, so this is probability of, you can say, minus 2, x is minus 2. This is probability of x is minus 1. Okay, but these two probabilities you are again going to repeat for the plus 1 and plus 2. So that's why I'm going to multiply by 2. Okay, so then ultimately it has to be 1. So you can solve further to get the answer. So from here you can say this is 2 into this is 3 whole square 9. Okay, this is 9k plus this is 2 whole square 4k plus k equal to 1. From here you can say this is 13k 26k and 27k, right? So k equal to 1 upon 27. Okay, and this is your answer. Okay, directly k is your answer. So I think C is the correct answer. Okay, 1 upon 27. It was also easy question, 1 mark question. Now let's just go to the next question. So in this question, they are just asking that if x is following some Poisson distribution. So by the way, what is the formula of Poisson distribution? Probability of x equal to k. This is e power minus lambda into divided by k factorial into lambda power k, right? So this is some formula that you should remember for the Poisson distribution. Now, which of the following equation must satisfy by the lambda? So basically they are saying that x equal to 1. So if you put x equal to 1, let me write here, probability of x equal to 1 is e power minus lambda. And since you put 1 here, it will be lambda only, right? Into lambda upon 1 factorial. So it is e power minus lambda into lambda. Probability of x equal to 0, if you want to find out, this lambda power 0 will be 1. So it is e power minus lambda only. Probability of x equal to 2, if you want to find out, it will be e power minus lambda into lambda square upon 2, right? So anyway, e power minus lambda is actually common in all, so it will automatically get cancelled out. So let's just solve it further. Now you just need to put probability of x equal to 1. Probability of x equal to 1 is e power minus lambda into lambda plus 2 into probability of x equal to 0, which is e power minus lambda, right? Equal to 12 into probability of x equal to 2, which is e power minus lambda into lambda square divided by 2. Okay, so e power minus lambda will get cancelled out. It will be lambda plus 2 equal to 6 lambda square, right? From here you can get the answer, it will be 6 lambda square minus lambda minus 2 equal to 0. Okay, so 6 lambda square minus lambda minus 2 will be 0. So B is the correct answer, right? Now let's solve this question. So in this question, they're asking expectation of by given x equal to 3. So which is basically summation over all the values of y, right? Now probability will be y given x equal to 3. So you need to find out the probability of y given x equal to 3, right? So let's just go to the next page and let's just try to solve this question. Okay. So from here, you can say probability of y given x equal to 3 will be probability of y given by comma x equal to 3 divided by probability of x equal to 3, right? Now, this joint probability is already given to you, right? If x is 3, then this will be 1 upon 9. I mean, the numerator is sorted, numerator is fine. So this is basically 1 upon 9 divided by this denominator you need to find out, right? So what is the probability of x equal to 3? This you have to sum over all the possible values of y in this joint distribution, which is x equal to x, comma, y equal to y. Okay. Now y values are running till x, right? Which means it will be running from 1 to x, 1 to whatever is the x, which is 3, right? So which means summation of y equal to 1 to 3 on this joint distribution is 1 upon 3x, right? Now since this is independent of y, so you can just say that okay, this will be 1 upon 3x plus, and x value is anyway 3, so this is anyway 1 upon 9. Okay, this is 1 upon 9. So this will be 1 upon 9 plus 1 upon 9 plus 1 upon 9 3 times, which is 3 times 1 upon 9, which is 1 by 3. So it will be 1 by 3 here. So from here, it will be 3 by 9, which is basically 1 by 3, right? Okay. So probability of y given x equal to 3 is basically coming out to be 1 by 3. Now we have to plug in this formula. Okay. So the formula of expectation of y given x equal to 3 is nothing but summing over all the possible values of y, probability of y equal to y given x equal to 3, right? Now this probability we have found out, okay, which is 1 by 3. This we have figured out, it is 1 by 3. Okay, since x is running, x is 3, so y will be 1 to 3. Okay, so it is coming out to be finally y equal to 1 to 3 y into this is 1 by 3, right? Now, which is nothing but 1 by 3 is common, 1 plus 2 plus 3, right? So 5, 6 by 3, 6 by 3 means 2. So expectation of y given x equal to 3 is coming out to be 2. So which means B is the correct answer. Okay, B is the correct answer. If you know any other way to solve this, you can just comment it out. But yes, this is the standard procedure to solve this question. Okay, now let's see this. Here they're just asking the rank of this matrix. Okay, I mean rank of A is this matrix, and then they're asking whether the solution exists or not, right? So what you can do, you can just have the row operations, elementary row operations. So if you do this, then you will be getting something like this, right? And since you are getting 0, 0, 0 and non-zero row, so you can say there is no solution, right? So no solution means that B is the correct answer. Okay, B is the correct answer. It is easy question. Now let's go to this question. If A is this such that A square is 0, then number of non-zero eigenvalues of A. Okay. So they are saying A square equal to 0, right? Now, uh, now can you directly say that there is one theorem called Kelly-Hamilton? Okay, can you use that Kelly-Hamilton theorem and then can you directly say that lambda square will be 0? See, Kelly-Hamilton theorem is basically work in the way on the characteristic equation, which means if you have some characteristic equation, okay, whatever it is, right, then you see the matrix also satisfy that equation. It's not the reverse way. I mean, it is working. This is called something minimal polynomial or something. Okay, you don't have to know about this, but it is working on the minimal polynomial or the characteristic equation. It is not like that. Okay, if some matrix is satisfying some equation, you can instead of matrix you can put the lambda. It's not like that. Instead of lambda, you can put the matrix. Okay, it's like that. So basically, if I just tell you, let's suppose a square is identity matrix. Can you say lambda square is 1 from here and lambda equal to plus minus 1? No, this interpretation is wrong. Okay, this is not the Cayley-Hamilton theorem, right? So applying Cayley-Hamilton theorem directly may have given you the answer, but it is a wrong method. Okay. So by the way, let's just assume that lambda is the eigenvalue of a, then ax equal to lambda x, right? If lambda is any or some whatever you want to write, right? Any eigenvalue. I mean, you can take any eigenvalue, it will satisfy, and the corresponding eigenvector, it will satisfy this, right? Now, if you multiply a both side, then it will be a into ax equal to a into lambda x, right? So left hand side will be a square x, right hand side will be lambda into ax, right? Lambda into ax is again lambda x, right? So it will be lambda square x. Okay. Now a square is given to be 0. So you can say lambda square x is 0. And since x is eigenvector and by the definition of the eigenvector that x cannot be 0. Hence you can say lambda square must be 0. Hence lambda must be 0, right? I mean you can take any eigenvalue, okay? Any eigenvalue. Then ultimately that eigenvalue has to be 0. So is there any non-zero eigenvalue? No, number of non-zero eigenvalues are 0. Actually all the eigenvalues are 0 only. Okay. All the eigenvalues are 0. So that's why A is the correct answer. Understood? So basically we are getting lambda square equal to 0 ultimately, but it's not like the by plugging in lambda directly here. Okay, it could be wrong. Okay. Now let's see this question. This question was like bit nice, I can say, but interesting question. So they're saying you have some matrix, okay, where each entry is minimum of I comma j, right? So basically ij could be I mean 1 to 50 basically, right? So 50 cross 50 matrix you have, and the first for the first row, like minimum of 1 comma j will be just, I mean j will be running from 1 to 50, so it will be just 1. For the first row it will all will be 1. For the second row, you will say that I is 2, but j is 1. So you can say even for the first column it will be 1, right? Okay, now coming to the second row, here both are 2, right? Both are 2, so it will be 2. And then 2 will be constant here because this is the second row, so 2 will be constant, right? Now, since it's third row, so it cannot be more than 3. The answer cannot be more than 3. So basically, 1. And then since the second column, so 2 will be like this. And then 3. And then ultimately 3, 3, 3. Right? So if you make the matrix, it will look something like this. Okay? It will look something like this. This matrix P will look something like this. Now they are just asking the rank of this matrix. Okay? They are just asking rank of this matrix. Can you see that how you're getting the second row using the first row? I mean, if you just add some vector, okay, if you just add one vector, what is that vector? You add, let's suppose 0 and all the ones, okay, if you add this vector to R1, then you will be getting this row, right? Similarly, you will be getting this row by adding 0, 0, 1, 1, 1, 1 to the second, you can say a row. So basically, second row you are getting, okay, you are getting the second row with first row plus 0 and then all the ones. Similarly, you will be getting the third row, okay, you will be getting the third row with second row plus some 0 0 1 1 1 1 1, and second row is already the summation of first row plus something, so you will be ultimately getting something like this. Basically what I'm saying, that second row is anyway the derivative of the first row, which means it will be r1 plus 0 1 1 1 1 1 plus 0 0 1 1 1 1. Okay, this will be your third row, right? Similarly, the fourth row will be R3 plus 0 0 0 1 1 1 1. Or in other words, fourth row will be, I mean, R3, which is this, right? This plus some one more vector 0 0 0 1 1 1, right? Now you notice that every row basically is a linear combination of these vectors, right? So every row is a linear combination of some vectors, which is R1 plus some vectors. R1 is actually ones, okay, plus these vectors basically 0 1 1 1 1 plus 0 0 1 1 1 1 1, right? Every row is something like this. I mean, every row is a if you want to find out the kth row, maybe you will be having first k minus 1 or k zeros here, right? So basically this is the third row, right? This is the third row where two zeros, I mean till two zeros, this vector is working, right? If you want to find out, let's suppose fifth row, then it will be 1 1 1 1 1, okay, all the ones, plus 0 1 1 1 1 plus 0 0 1 1 1 1 plus 0 0 0 1 1 1 1 1 plus 0 0 0 0 something like this, right? I mean, there will be 40 till 40 if you have, then you will be getting R5. Now notice here is that all of these vectors which you are adding are linearly independent. Why I am saying so? Because whenever you have, a zero here, and with the zero, whenever you have corresponding non-zero, then obviously you cannot get, I mean, if you want to get this, then you have to multiply by the zero. I mean, these two have to be linearly independent, right? So if you have any non-zero, so basically with this corresponding zero, you have the non-zero one here, okay? With this corresponding zero, you have non-zero one. So that's why these two are linearly independent. With this corresponding zero, you have non-zero one. With this corresponding zero, you have non-zero one. So actually all are linearly independent. Okay. And see, generally we have these basis vectors, right? Why you think these are linearly independent? 0 1 0 0 0 1. Because you cannot get this, okay, from this, because this is non-zero and this is zero. So you cannot get this from this, right? Okay. Or if you want, I can write these vectors as a column vectors just to show you that these are actually linearly independent. I mean, all the ones, right? And then 0 1 1 1 1, and then 0 0 1 1 1 1 1, then 0 0 0 1 1 1 1, then 0 0 0 0 1 1 1 1, right? So obviously all are linearly dependent here, right? If you just flip this, and if you just see this is a pivot, okay, I mean the last one will, you can see a pivot, and then the pivot is here, then the pivot is here, then the pivot is here. I mean, if you just see from the downwards, then you will be seeing, okay, these are the pivot. Anyway, like what I'm saying, that all of these vectors are linearly independent, right? All of these vectors are linearly independent. So basically the rows are linear combination of some linearly independent columns. So you can say these are the few vectors, okay? So if you want, see, there are 50 rows. So this vector plus till 49 zeros. So basically there will be 50 vectors. I mean, including this, there will be 50 vectors. So R50 will be linear combination of 50 vectors. See, R3 is a linear combination of 3 vectors, right? So similarly, you can say R5 is a linear combination of 5 vectors. So R50 will be linear combination of 50 linearly independent vectors, right? So any row here in this matrix is a linear combination of so some of these 50 vectors, right? So using those 50 vectors, you are making this matrix. So that's why you can say that rank of this matrix will be 50, right? Rank of this matrix will be 50 because you're ultimately consuming all those 50 vectors, right, till the last row. So that's why D is the correct answer here. Okay. So I have also, written the solution in the similar way. You can see the third row will be like this and so on. Okay. So 50 is the correct answer here. Now let's see this question. This was easy question. Like they are just asking eigenvalues or the trace of this matrix B. So eigenvalues of V will be 1 upon lambda plus lambda square. So what you can do, you can just sum this 1 upon 1 plus 1 square plus 1 upon 2 plus 2 square plus 1 upon 3 plus 3 square, because trace means summation of all eigenvalues. Now, if you do so, I think it was coming out to be 95 divided by 6. So B is the correct answer here. Okay. Now let's see this question. In this question, they're asking dimension of V. V is what? V is a vector space of all x such that Ax equal to 0, which means they're asking dimension of null space. V is a null space, right? Which is same as saying they're asking nullity, right? Which is same as saying they are saying number of columns which are three minus rank. I mean, they are just asking rank of this matrix. You can just subtract three minus rank will be your answer. Okay. So you just need to find out rank of this matrix. That's all they're asking. So you can just do the elementary row operation. Then rank is coming out to be 2. Then nullity will come out to be 1. Okay. And then 1 is the correct answer. Now let's solve this question. So here they are just asking the values of a and b, or they are asking a plus b basically. Okay. So since the function is differentiable, it has to be continuous. Since the function has to be contiguous, so which means you have to satisfy one thing, that uh, that the function value less than 0, okay, and the function value greater than or equal to 0 will be same, right? So just before 0, which means limit x tends to 0 minus the function is a sin x upon x minus 2, right? This value will be, since this is 1, this value will be a minus 2, and this value will be anyway 0, right? So with the continuity you can say a is 2. Okay, with the definition of continuity you are getting a is 2. Now you need to find out b also. You can use the definition of differentiability here, right? How to use that definition? You can say that just after 0, which is bx, okay, the differentiation of this, right, the f dash x, you can find out just after 0. Okay, this is b. What about less than 0? What about the differentiation of this? You can directly differentiate if you want to differentiate. Otherwise, you can use the formula of limit for the differentiation. I mean, if you want, you can totally directly differentiate. I mean, there is no problem. Just like I've differentiated this bx. Okay, you can also differentiate this, right? Or you can use, if it is little complicated for you, then you can use that formula of differentiation. I mean, you can say f dax 0 minus, I mean, just before 0 I'm just using this formula, so I'm writing 0 minus f of, you can say, um, so basically we want to find out f of 0 minus, right? Yeah, f of x minus f0. So it will be f of x minus f0 divided by x, right? Or x minus 0, doesn't matter. So you can use this formula, or you can directly differentiate this thing. Okay, you can directly differentiate. So if we use this formula and then we find out the limit, then it is coming out to be 0. Okay, it is coming out to be 0. And then 0 plus, you can directly differentiate here also, or you can use the formula, this kind of formula here also. I mean, if you use this kind of formula, there won't be any use. It will be like bx minus f0 is basically 0 upon x, so it will be just b. Okay, I mean, you can use this kind of formula here also, but you can directly differentiate if it is easy to differentiate. So you are getting b, and then b equal to 0. Okay, and a was 2, so a plus b will be 2. Okay, a plus b will be 2. So 2 is the correct answer here, right? So I hope you understood. This was easy question, not that much tough. Now let's move to the next question. So let's see this question, what they are saying. So they have given some algorithm, and then they are saying which of the following statement is true at the beginning of the iteration I, at the out at the outer loop. So basically, what does this mean? This is very popular, which is called loop invariant. Okay. So about loop invariant, let me tell you. Basically, it means that, let's suppose some algorithm is using some loop, right? For of something or something, right? It need not to be nested loop. It could be one of the loop. Okay. Okay. Just one loop, two loops, doesn't matter. So loop invariant means that, let's suppose, let me take the example of insertion sort. Okay. Let me take example of insertion sort. See, in insertion sort, what we know that that whatever we do, right, we know that this part, let's suppose, I mean, we are running the algorithm, and then in each iteration we pick one element, we try to fit this element, right? You might remember insertion sort. Okay, so one thing is for sure that in every loop, right, before starting every loop, okay, you know that this part is sorted, right? This part is sorted. So this is called loop invariant for the insertion sort. Okay, because there is a loop, and in that loop that you know that, okay, before you start that loop, that this part is already sorted, right? I mean, this is called loop invariant. You don't have to know much about this to solve this question, but I'm just telling you that there is a topic called loop invariant, and this particular question is related to loop invariant. Which of the following statement is true at the beginning of iteration I? Okay, so which means that at each of this iteration, okay, at the beginning of ith iteration, before you start executing this inner loop, okay, which means for the outer loop they're asking the loop invariant. Okay, so let's just do one thing. Let me just take this algorithm on the next page, and then we have to dry run this algorithm to see that what is happening here, right? So let's just try to dry run for some example. Maybe let me take some initial array. Okay, suppose this is 5 4, or maybe 5 3 3 4 2 1. Okay, suppose this is the initial array. Now, what they're saying that you will be running till n minus 1. So basically the indexing is from 1 here, 1, because you can see that indexing is from 1, array is 1 to n. Okay. So indexing is from 1. So basically this is 1, this is 2, this is 3, 4, 5, right? Something like this. Now, what they are saying that you will be running the outer loop till n minus 1. I mean, you will be running till this point, and the inner loop you will be running. The inner loop you will be running till I minus 1. Okay. So initially I is 1. Initially I is 1. Let me run the inner loop. Okay. Then j will be from 1 to 0. I mean, it doesn't, it will not get executed. So initially, let me just take I equal to 2. If you take I equal to 2, then j will be from 1 to 1. Okay. And 1 to 1 means, yeah, so I think, yeah, let me take I equal to 2. So j value will be 1. I mean, it will run for only 1. Okay, j value will be 1, will be 1. It will check whether this is j. Okay, it will check, and I value is 2, which means I is fixed here. Okay, I is 2 here. Okay, which means it will check every element with this element. Okay, it will check basically this element. If it is greater, right, then it is saying swap, which means it is saying that give smaller elements to me. I mean, this prefix part is saying give smaller elements to me, which means for I equal to 2, j will be 1. In that case, the array will be, finally the array will be like this. So basically this is a of I. Okay, it was a of I. I mean, a of I is 2 basically. A of I was 3, but once you swap you will be getting this a of I. Okay, so you're saying that I'm going to swap. That's fine. Now let's just take I equal to 3, and then j will be 1, and then j will be 2 also, right? I mean, j will be 1 and 2. I equal to 3 means that now you are comparing every element with a of I. A of I means 4. Okay, you will be comparing with this. So let's just try to iterate it. So basically, if it is, it basically, this part is demanding the smaller elements. So this is already smaller. That's fine. I mean, for j equal to 1, you will say, okay, this is smaller, that's fine. For j equal to 2, whenever j is 2, since it is greater, you will just swap, right? So finally, for j equal to 1, there is no change, but for j equal to 2, this will be finally like this, right? Now you might notice one thing, that uh, so just notice one thing, that whenever I is equal to, let's suppose I equal to 2. Okay, or maybe I, like before the I equal to 3, you can say this part is sorted, then again this part is sorted, right? Then again this part was sorted. So basically you can say till a of I, right? So till a of I, you can assume that it is sorted. I mean, you can run this algorithm more and then see what is happening. See, for I equal to 4, for I equal to 4, you can say this was the initial array. This is the initial array for I equal to 4, and j will be running for 1, for 2, and then for 3 also. J will be running for 1, 2, 3, right? So J equal to 1, equal to 2, equal to 3. Now, uh, now this is the initial array, right? For I equal to 4. Let me just remove this. Now you will be basically comparing every element with this 2. Now since this is greater, you will be just swapping. So it will be 2, 4, 5, 3, 1. Now you will be comparing every element with 3. So since this 4 is greater, you will be again swapping. So it is 2, 3, 5, 4, 1. And then this 5 is also greater. So you will be again swapping, right? So finally you got this, right? So you can say that whenever you are starting I equal to 4, the first three elements are sorted, right? So which means whenever you are starting for I till I minus 1, you can say it is sorted. Till I minus 1 it is sorted. So hence A is sorted, no, till I minus 1, before starting any iteration I, till I minus 1 you can say it is sorted, right? Can you guarantee something else also is sorted and x is less than A of I, where x belongs to basically any element in this prefix, okay, is lesser than equal to A of I. See, currently A of I you have not even seen. Okay, A of I you cannot guarantee because before starting I equal to 4, for example here, right? You cannot guarantee. It could be any element, right? It could be 100. It could be any element, right? So you have not seen this. Okay, I mean what is happening till A of I you don't know is sorted and x is less than equal to y for all x belongs to A. So basically they are saying and by belongs to A. No, till this AN and these claims we can't do, right? AN and these claims we can't do. We do not know anything other than that, okay, till 1 to I minus 1, it is sorted. So it was good question and B is the correct answer here. Okay. It is also kind of working like insertion sort. In insertion sort also, like what we do, we take one element and then we try to fit it. Here also we kind of taking two. We are not fitting it directly. Instead what we are doing, we are just swapping it with whatever is the first eligible candidate. And then okay, we are swapping it with whatever is the first eligible candidate, and then that eligible candidate is actually going to be here, right? And the same process we are repeating. I mean, like we are shifting, but we are shifting in some dramatic way. I mean, we are not shifting directly, right? We are not saying that 2 is coming here and let's just shift then, just like insertion short. We are also shifting. I'm not saying we are not shifting, but we are shifting in some other dramatic way, in the sense that we are saying that okay, who is the first eligible element to swap with 2, right? Or which means who is the first element which is greater than 2. So 3 is the first element which is greater than 2, so I will swap. Now, see, it's not like I'm always comparing with 2, like a pivot or something. I mean, 2 is a pivot. No. Now, this 5 and 3 will get compared, or 4 and 3 will get compared. See, we are going to compare these two also, but not when they are adjacent. Whenever 3 is going to be here, at that time, I'm comparing this 4 with 3, right? So basically these elements are also getting compared, right? Ultimately it is coming out to be 2, 3, 4, 5, just like shifting, right? If you notice, ultimately it is coming out to be shifting, but in very dramatic way. Okay, first I'm swapping with 2 with the first eligible greater candidate, then 3 will be here, then 3 will be swapped with the next eligible greater candidate, and then this 4 will be swapped with the eligible greater candidate, and ultimately it is just like a insertion sort. Very nice algorithm, I can say. So correct answer is B, right? Now so let's solve this question. This is easy question. So what they are saying, let's suppose there is a function which is order of n square, which means this function f1n is basically less than equal to n square and greater than equal to n, right? Which means it is somewhere between n square and n. F2 is just n square. So now they are saying that f1n plus f2n is n square. Yes, obviously this is less than equal to n square. So, and this is n square. So n square will definitely dominate. So statement 1 is true. What about statement 2? F2, which is exactly n square divided by f1. which could be n square also. Okay, has to be at least greater than or equal to n. No, it could be 1 also, right? I mean, it could be 1. It is not needed to be like, at least it is not I mean, it is, this is not greater than, you can say greater than or equal to n. This is just 1. 1 is not greater than or equal to n, right? So that's why this is false. So statement 2 is false. Statement 1 is true and statement 2 is false. So B is the correct answer here. Okay. Now let's solve this question. Here they are saying a queue maintains n elements and an empty stack S is available. You need to transfer all the elements Q to S in such a way that front element of the queue, okay, becomes the top of the stack. Which means, suppose there are like 1 2 till 9 till n elements, then front element, which means this is the front, right? This is the front, should be the top. Which means ultimately this should be the situation. Okay, n minus 1 n minus 2 like this. Okay, so, and all the relative orders of all elements are also preserved. You are allowed to perform only NQ, DQ, push and pop. What is the minimum number of NQ that you have to do to complete this transfer? So basically, what they are saying is something like this, that you have this queue and this stack, right? You want to transfer all the elements from here to here in such a way that stack. So here the front element is 1. Okay, so stack must be having 1 at the top. Okay, 1 at the top. This is what they are saying. Stack must be having 1 at the top. So what you can do, you can transfer all the elements first from queue to stack. So this is the final stack that we want, right? So let's just see that how to get this stack. Let me just put this on the side. Okay, first you can do one thing. You can transfer all of these elements. Okay, just like this. If you transfer all of these elements, then in that case 1 will be at the bottom. Then ultimately we want 1 to be the top, right? So you can transfer all of these elements. Then q will be empty, right? Then q will be empty. And then you can transfer back so that n will be at the bottom. Okay, so if you transfer back, then this will be like this, 3 to 1. I mean, n will be at the bottom. Okay, right? And then this will be basically empty. Now you can transfer all the elements from here to here. So basically n will be, again, now n will be at the bottom in this case, which means n is at the bottom. Then 1 2, sorry, then 1 2 3, right? It will be like this, and then q will be empty. Okay, you can do something like this. But here is one small catch, that you do not need to transfer all the elements from here to here. Okay, you can just keep this n. So basically we are transferring n minus 1 elements from here to here, and then we are keeping this n as it is, right? Because if we transfer all the elements, then n will be anyway at the anyway here. So we want to save nq operations, right? So you can just keep one element here, and then you can transfer all of these elements. So it will be 1 to n anyway, right? So how many nq you have done till now? N minus 1 nq, right? And then you can just dq, and then you can do your thing. So basically n minus 1 nq you need. You don't need n nq. So which means B is the correct answer. Okay. So it was a good question, and B is the correct answer here. N minus 1 and Q are required. Now let's solve this question. So they are saying that you are using the partition method that we use in the quicksort. A partition selects the pivot and rearrange the array so that all the elements left of the pivot are less than or equal to pivot, and all the elements right of the pivot are greater than or equal to pivot. See, in the quick sort, let's suppose we apply the quick sort. Then let's suppose these are the sum numbers. I'm not writing the number in an array for some reason. Okay, I will just tell you that why I'm writing just like this. So suppose the numbers are 5, 9, 7, 3, 2, 1, right? Something like this. Now, whatever pivot you choose, let's suppose 3 is the pivot. Okay, based on any criteria, you can choose any pivot. Then quick sort. Okay, based on the quick sort, let me just tell you, quick sort just says that I will just partition, or the partition method just says that I will partition in such a way that less than equal to 3 will come here, okay? And greater than equal to 3 will come here, which means 7, 5, 9 will come here. Now, why I'm writing this, why I'm not writing like an array, to highlight one very important point, which is that the relative order of this 597, like whether 5 should come after 9 or 7, I mean, it should be adjudged like this or not. This is not, not determined by the quicksort. I mean, you can do based on your implementation. So, as per the theory, as per the algorithm just says, or the partition algorithm just says one thing. I will partition in such a way that less than equal to 3 are here, greater than equal to 3 are here. It does not say anything about the relative order of 579. See, although this is not important to solve the question, okay? So to solve this question, it is not important. But still I'm telling you about the quicksort, okay, or about the partition method used in quicksort. The quicksort doesn't say anything about the relative orders of these elements, okay. The quicksort doesn't say anything about the relative order of these elements, anything about the relative orders, or relative order of these elements. Yes, using the implementation we can talk about the stable sort or non-stable, not stable, or something like that. But as a theory, quicksort doesn't say anything about the relative order of these elements, right? Okay, just telling you one fact, because some of the student doesn't know this fact, right? Now let's just see what is the answer. So see here, that can you see any of them could be the pivot? If you choose 10, then less than equal to 10, no. Here, okay, 20, no, this is 50. So basically 60 could be the only pivot, but greater than 60 should be here. So that's why because of this 50, I was just assuming that 60 could be the only possible pivot here, but greater than equal to 60 should be on the right side, which is not there. So A is not the correct answer. What about this? Yes, I think 30 could be the pivot, and less than equal to 30 and greater than equal to 30 are satisfying the condition. So 30 is the pivot. So that's why B could be the correct answer. What about this? See, this is interesting. This C is interesting. Here, um, 30 cannot be the pivot because less than 30 are not there, right? 20 cannot be the pivot because 10 is here. If you see, anyone cannot be the pivot, but 60 can be the pivot because less than equal to 60 are already here, right? So 60 is the pivot. So C is the correct answer. What about D? It is sorted in the reverse way, right? So they are saying that less than equal to pivot are on the left side and greater than equal to pivot on the right side. So obviously none of them could be the pivot. So that's why B and C are the correct answers. Okay. B and C are the correct answers here. Now let's solve this question. It was easy question. So there was one list which is having A, B, C, and then list of one. I'm replacing this B with some other list which is X, Y, Z. Okay. I'm replacing with some other list. Now I'm saying that X is basically list of one. List of one means X is kind of pointing to list of one. Okay. And the y equal to X means Y is now also pointing to list of one. Then y of 0 is equal to p, which means y of 0 means this element. Now I'm replacing this with p. Now they are saying, what is this list? Since in Python everything is object, and these things means that y is pointing to x is pointing to list of one, y is also pointing to whatever x is pointing to. Okay. So basically list one originally got modified. So that's why the answer is B. A, P, Y, Z, and C. Okay. Originally like list one got modified. So that's why answer is B. I hope you understood. That was easy question, but still, it was solvable only to those who know that in Python, this is like everything is just reference. Now let's solve this question. Here they are saying that defining something called local minimum. They are saying that a vertex is called local minimum if its label is smaller than the labels of its all neighbors. Okay. Neighbors including the parent and children. Now they are saying that this is some algorithm to find out the local minimum. I mean, minimum, as you know, that okay, is smaller than every neighbors, right? So start at the root. If the current vertex is local minimum, then stop. Otherwise, go to the child with a smaller level. and then repeat. So basically they are saying in the tree you want to find out the local minimum. Okay, local minimum means that it should be smaller than child. It's every neighbor, which is including children and parent. So basically they are saying you go to the smaller. Okay, you wherever you find the smaller, it is not binary search tree, it is just a normal tree. So you can find the smaller at the left hand side or the right hand side. Okay, so wherever you're finding the smaller, let's suppose this is smaller, go here, then go here, like that, right? So wherever is smaller. If nothing is smaller, then this is basically the local minimum, right? Then automatically you will be stopping at the local minimum if nothing is smaller, right? See, you're coming here because it is you are smaller than the parent, right? Then only you are coming here, and then you are not able to go down, right? Because let's suppose nothing is smaller, then this is the local minimum, right? And if you're able to go down, then you can go till the leaf, and you're coming till the leaf only when the parent has sent you, and the parent is saying that I'm not a smaller, you are the smaller, right? And since there is no children, then you will say I'm the local minimum. I mean, you will anyway stop at the local minimum, right? So you will stop at the local minimum, and since you have to go till the height only, and the complete binary tree is given, so that's why height is log n, right? Height will be log n, so it will take log n time. Algorithm may visit the vertex more than once. No, it is not possible. Along the execution algorithm, the levels are visited vertices are forming a strictly decreasing sequence. Yes, you will go in the decreasing order, right? You will go in the decreasing order. So that's why this is also true, because there are distinct integer levels. So that's why you can say this is strictly decreasing, because the numbers cannot be same. So it is not like non-increasing or something like that. It is strictly decreasing. You have to decrease it, right? Because the numbers cannot be same. So A, B, and D are the correct answers here. A, B, and D are the correct answers, right? It was easy question, 2 mark question, right? It was 2 mark question, which was easy question only. Now let's solve this question. This was also a good question. Here they are saying that you have n integers, but there are many repetitions, such that only k integers are distinct. And you know the frequency of every integer, right? And that has been saved in the hash table of size k. And the frequency you can get in order of one time. Now, which of the following algorithm is correct? So basically, you have n integers, but only k are distinct. And now they are saying you may assume that frequency of each distinct has been computed and sorted. Okay, and retrieving is taking order of one time. Now they are saying that how much time it will take to sort all of these integers, right? So what you will do, you will take the hash table, you will get each of the element, and then you will be having your k elements, right? K elements here. Now you can sort these k elements in k log k time, right? You can sort these elements in k log k time, and then let's suppose after sorting, let's suppose I get 3, some element was 7, some element was, let's suppose, 15, and then let me take something like 8, and then let's suppose 9. Okay, these were the elements which were distinct elements, and then these are the repetitions. Maybe 3 is coming 2 times, maybe 7 is coming 2 times, maybe 8 is coming one time only, let's suppose 9 is coming 2 more time, or something like this, right? So there are repetitions will be here. And then you can take k log k time to sort this, right? K log k time to sort this. Now what you can do, since you have the frequency, I mean, you don't have to write this, or this is just for the understanding purpose. So basically, once you have the frequency, you know that 3 is coming, total 3 is coming 3 times, so you can write it 3 times, right? I mean, you have the sorted sequence, you can pick the 3, and then you can write it 3 times based on the hash map, right? It will tell you, okay, how many times you have to write? 3 times. Okay, total 3 times. Then 7, how many times you have to write? Total 3 times, right? Total 3 times. Then you can write total 3 times. 8, how many times you have to write? Total 2 times, right? Total times you can write. 9, how many times? Total, I think 3 times, right? So 3 times you can write like this, right? And since you're writing all the n elements, so it will take additionally n time. So k log k plus n. This will be your time. K log k plus n. Okay. So k log k plus n will be your time for sorting. The sequence can be sorted using this time complexity. Okay, so B is the correct answer. Is C also the correct answer? Can C be the correct answer? K log n. See, K log n and these two are different. Basically, K log n, these two are different for some values of K. For example, if you put K equal to log n, okay, K equal to log n, then K log n will be log n into log n, right? But this is n plus something, right? So basically, this log n into log n definitely lesser than n. I mean, this will at least take n time. So n plus K log K is the correct answer. Okay. C is not the correct, or log n is not the correct, and so on. Okay. So B is the correct answer here. I hope you understood this question. It was easy question, nice question, I can say. Okay. If there is any difficulty in this question, then it could be because you might not have practiced these kind of questions. But it was, I think, very easy question. You have to sort the k integers only, right? I mean, you don't have to do anything else other than sorting the k integers. So that's why k log k time it will take, and then n more time it will take. Now let's see the next question. Okay. So this was related to probability, and then they are asking that which of the following statement is not true. They are saying that probabilities are strictly lesser than one and greater than zero. Okay, both of these probabilities. Now in this question, actually, option A and option C are very straightforward. So probably let me just tell you first about option A and C. So let me go to the next page and let me first tell you about the option A and option C. Okay, because they are very much straightforward. So option A is saying, okay, option A is saying the probability of A given B is greater than PA, right? Then they're asking B given A is greater than PB or not. See, there is nothing specific about the A and B, right? So you can definitely switch A and B, which means using the symmetricity, you can say that you can switch A and B. Then probability of B given A is also probability of I mean B given A will also be greater than probability of B. Okay, I mean you replace A with B and B with A. I mean based on the symmetricity, you can say, or you can also solve this. It's not a big deal to solve. So basically they are saying that this is probability of A intersection B is greater than probability of PA into PB. PA into PB. I mean, it was divided by PB, but I'm just taking PB here. Okay. Now to write B greater than A, basically I need to write this PA down, right? So which means probability of A intersection B divided by PA. Okay, greater than PB. So which is same as this option. Okay, which is same as this option. So you can say yes, option A is true, right? They're asking not true or not correct. So but option A is true. Okay, so option A and option C are actually very easy. So that's why I'm taking these two options first, and option B and D we will see after that. So let me just tell you about option C now. Okay, so let's just see option C now. So it is saying probability of A given B is greater than PA, right? Now, now here they are just saying B, right? I mean, they are not saying B complement or something, which means they are asking the same domain. Domain means like same conditional probability, right? Same B. Okay. So what you can do, you can basically convert, I mean, this to A complement. So how to do it? You can multiply minus one both side. The moment you multiply with a minus one both side, the inequality will be reversed. Okay, which means it will be less than minus of PA. Now you can add one both side. Okay, so if you notice here that the this is basically B's complement, sorry, A's complement. So basically this is same as probability of A complement given B. Yes, right. So this is probability of A complement given B less than probability of A complement, right? So yes, this is MSC. Okay, this is MSC. So that's why this is also true. Okay. So these are the two options. Now let's just see other options which are B and D. Okay. So let's just see option B and D. So option B is saying if probability of A union B is 1, right? It is given to be 1. Then they are saying that these two cannot be independent. Remember that it is already given that both of these probabilities are strictly less than 1, right? It is already given to us, right? For all the options, we have to obey this particular inequality. So basically, this is already given to us, right? Okay. Now, now let's just do one thing. Let me write it in this way. 1 minus, I will be writing P A union B complement, right? Basically it is just I'm saying that probability of A equal to 1 minus probability of A complement. So instead of A, I'm applying it to be A union B. Okay, this will be 1 minus probability of A. Now using the De Morgan's law, so what we can do, A complement intersection B complement, right? So basically I wanted to convert this A union B to intersection. Okay, somehow I want to convert this, because then only the independent will make some sense. Okay, I mean for the independent, if they're independent, now I'm assuming they're independent. If they're independent, then it must be like this. Okay, if they're independent, then A complement and B complement are also independent, and using the independence, okay, using independence, I'm able to write like this. Okay, assume they are independent. So basically the question is about the independent, so that's why I wanted to convert this union to intersection, and this is the standard way to convert this union to intersection. Okay, now since they are saying that probability of A and probability of B are both are strictly less than 1, so basically either you can directly see from here, or otherwise let me just convert that to A and B also. So basically you can say this is equal to 1 minus 1 minus probability of A into 1 minus probability of B. Okay, so these two quantities are strictly lesser than 1. So basically this is strictly greater than 0, this is also strictly greater than 0. I mean, this probability of A complement, B complement are actually greater than 0. So basically ultimately it will be less than 1. But since it is given to be 1, so that's why my assumption is false. Okay, so I cannot go from here to here. The moment I go from here to here, it cannot be exactly equal to 1. Okay, so that's why I can say that that they are not independent. Yes, this is true, because they I mean using the independence I'm getting something contradiction. Basically if I use the independence, then ultimately I will be getting this as less than 1. Okay, which is not true. So they cannot be independent, right? They cannot be. So yes, this is true, this is also true. Okay, so I hope you understood about the option B. This is also true. Now let's just check the last option, which is option D. Okay, let me copy this again. So A and C was straightforward. Now option B is also done. Now let's just check option D. Okay, in option B I have converted this union to intersection. That's the only thing we have done. Option D is also not that tough. Let's just check whether it is true or false. So they are giving that probability of A intersection B is greater than PA, right? Which means it is same as probability of A intersection B is greater than PA into PB, right? This is same as this. Now this is basically given. Okay, you can say this is given. But we want to find out, okay, but we want to find out a relationship between this. Okay, so relationship between probability of A complement intersection B complement divided by B complement. So I'm writing it here, probability of A complement into probability of B complement. I mean this is basically to be figured out. Okay, so this is given. So let me go to the next page. So basically what is given? Given is probability of A intersection B is given to be greater than probability of A into probability of B. Okay, what they're asking is a relationship between when everything is complemented here. Okay, so which means they're asking the relationship between probability of A complement intersection B complement and probability of A complement into probability of B complement. Okay, they're asking the relationship between these two. I mean greater, lesser, equal, whatever, right? I mean the relationship they're asking. Okay, great. So now let's just solve this question. See, whatever is given, I have to convert to that so that I can draw some conclusion. So what we can do, we can convert this to A complement B complement by a simple hack, which is, again, I mean I will be again using the same thing. Okay, I'm writing this LHS. You can say this is LHS basically. Okay, so this will be same as 1 minus. You can just open this. It will be A union B. Okay, 1 minus. I think that's correct. A union B. Right? Okay. Now let me just again open this up. Probability of A union B means probability of A plus probability of B minus probability of A intersection B. Actually, I'm just converting everything to A and B, and then I'm again converting to intersection instead of union so that I can draw some conclusion. Okay. So this was LHS. Now, what about the RHS? RHS, I think very easy. So probability of PA, you can write it. I mean, I want to convert that to everything to P and PB. So you can write like this. So basically you can say, let me write this given like this here. Okay. And then they're asking this, right? So yeah, so whatever is being asked, let me just write that also. Okay, so this is A complement, this is B complement, right? So now can you draw some conclusion from here? Let's just try to draw some conclusion. So LHS is this and RHS is this, right? So which is greater? What do you think? Which is greater, which is lesser? Maybe I can do some simplification. Maybe after that we will be able to see this little better way. Okay. So let me do some simplification. This is 1 minus PA minus PB plus P A intersection B. Right. This is 1 minus PA. Right. I mean 1 minus PA multiplied by 1 will be 1 minus PA. Then minus PB will also get multiplied. This is minus PB plus PA into PB. Right. Okay. I think 1 and 1 will get cancelled out if I compare. Minus PA is getting cancelled out. Minus PB is also getting cancelled out. So finally, I'm getting, as an LHS, I'm getting this. As an RHS, I'm getting PA into PB. Right? And which is already known to be greater. I mean, from the given, you can say it is already known to be greater. So hence, these all are greater, right? I mean, from starting, it is a greater symbol. So which means this is actually greater than this. Okay. So which means this is false, right? This is false. This is actually greater. So that's why you can say this is answer. This is answer. I mean, since this is false, okay, this is false. That's why D is the correct answer. Okay. So you just have to apply some combination here and there. Some, like, the only thing that we have done in this question is to apply that how to convert intersection to union or how to convert A complement to A. Okay, something like this, right? You can just practice this question once more, see that what is needed and what should be done. Right here in this, we don't have to do much. It was easy calculation. C was very straightforward because the domain is same. I mean, the given conditional is same, so that's why it was very straightforward. For B and D, we have done some calculation, right? Since they are talking about the independence, so that's why I have to convert this union to intersection, right? To see that what is happening. Okay. So yeah, D is the correct answer here. Answer is D. Okay. Now let's solve this question. This was easy question. They are just asking that x transpose y, the value of x transpose y. Since x and y are the vectors, so that's why x transpose y will be the scalar. Okay, which will be having 64 terms. I mean, there are the 64 terms. The first term will be z1 into z65 plus second term will be something like this. Okay, and so on. Okay, this will be x transpose y. Now expectation of this will be expectation of this plus expectation of this and so on. Now, since every z is independent, so that's why expectation of each term, okay, any term you can take here, for example, z1, z65 or any term, you can write it like this, z1 into expectation of z65 because they are independent. So expectation of one individual term, so expectation of z1 is anyway, the probability is 0.5. So this is Bernoulli, so it will be 1 by 2, it will be 1 by 2. Okay, 1 by 4 is the expectation of one term. Since there are 64 such terms, so that's why it will be 1 by 4 into 64, which is 16 is the correct answer. Okay, it was easy question. So you can see this is 64 such terms, so that's why 16 is the correct answer. Now notice here is that this expectation of x into y is equal to expectation of x into expectation of y only when they are independent. Otherwise there will be plus covariance term. Okay, so this is very important, that otherwise there will be a covariance term, right? So that's a very important formula, and sometimes it could be directly used with the covariance also. So you should be knowing this formula, right? Great. So now let's just move to the next question. So this question was easy, to be honest. This question was related to k-means, but here some small things were there. So I hope you were able to solve this. Otherwise, like we are going to solve this obviously, but this question was actually a bit tricky in only one sense, that we generally overlook few of the things. Otherwise, this question was easy. Okay. So we should be. This question is basically telling us that we should be careful in reading the question. That's all. So this question is saying that you have k-means algorithm, and k-means objective function is given here, right? I mean, k-means basically minimizes this objective function. We have seen this in the class. Otherwise, if we are not go classes student, then it's fine. Like this is a standard k-means algorithm, and now they are saying that let's suppose ci with a cluster assignment for point xi, which means which means point x1 is basically mapping to C1, right? Now C1 could be I mean this cluster number could be anything. So basically point x1 can go to, let's suppose, cluster number 5, cluster number 6, like that, right? Something like this. Okay. And mu j is the central for the cluster J. Now they are saying consider the extreme case where the number of clusters are equal to number of data points, which means k equal to n. Which of the following statements are always correct? The optimal cluster assignment, okay, satisfies ci star is equal to I for all I equal to 1 to n. So basically they are saying that optimal cluster, if you have n, if you want to make n clusters, then basically every data point x1 will belong to just one cluster. I mean, basically there will be n clusters, right? Because k is n, so there will be n clusters, and each cluster will be having exactly one data point. X2 will be belonging to exactly one cluster, and I mean, basically you can say, in other words, you can say each cluster will be having exactly one data point, right? Xn will be basically some cluster. Now x1 is belonging to the cluster number 1. Is this, I mean, the assignment, the numbering, that it will be belonging to cluster number 1 is not guaranteed. I mean, it can belong to cluster number 5. So basically ci will be I. This is not guaranteed. I mean, this can happen, but it is not guaranteed to happen. So that's why A is false. Okay, just it is just a question which is requiring your little bit attention, that you should be reading the question carefully. So basically, it's not like that the x1 cluster will be numbered as 1. Okay, it could be numbered as 5. Because the cluster numbers are arbitrary. I mean, it's not like that it will be basically numbered, it will be numbered as 1 or something like this, right? The optimal centroid corresponding to the cluster I is given by, see, they are saying the optimal centroid for the cluster I. See, it is first of all not necessary that in the cluster I you will be having xi. In the cluster I you can have xj also. I mean, there will be just one point, which is correct. I mean, see, if it is xj, then this is correct, where j could be anything from 1 to n, because the centroid will be just one point, right? Which is okay, but it is not necessary that cluster I centroid will be xi only, because xi need not to belong to cluster I. So both the options are basically aiming to test only one thing, that the cluster assignments are arbitrary. Okay, so that's why this is also false. But yes, at the optimal, the objective will be 0, because this objective is basically finding out the distance between the cluster centroid and the point. Since the cluster centroid will be the same as the point, so for every cluster, so that's why the optimal will be 0. The loss function will be 0, or the objective function. This is also the loss function of k-means. Loss function of k-means. The optimal centroid will be given by, no, optimal centroid will be just xj, okay, for some j. Okay, it will not be, average of all the j's or something like that. It could happen if there is just one cluster. For k equal to 1, it will be the case. For k equal to 1, yes, the optimal centroid will be the average of all, but for k equal to n, this is not true. So you can say c is correct here. Okay, c is correct. So the condition ci equal to I depends on the labeling of the cluster. Since cluster index are arbitrary, this need not to hold an optimal solution. Okay. Now let's see this question. What this question is saying, that Adam has proposed a new algorithm called perceptron trees, which combines the ideas from decision tree and perceptron. Perceptron trees work like decision trees, but instead of using majority vote at each leaf, they are using the perceptron. So basically, this is just like a decision tree, but at the end, you are using here you are using the perceptron. Okay. Now suppose you have trained the perceptron, and the weights of the features used in this perceptron are given here, which is obviously given in the question. They are saying that each leaf is okay. The perceptron at the leaf uses the indicated subset of features such as CDEF. Either this is CDEF or BCEF. Either this is CDEF or BCEF, like that, right? Okay. Now, the structure is given below. Now they are saying for the input A, B, C, D, E, F, for this input, the predicted output will be what, right? See here, if A is 1, and then you need to check D, right? If D is 1, D is also 1, then basically you have to apply this particular perceptron. You are ending up in this leaf. Now you have to apply this particular perceptron, right? So what is the formula for the perceptron? W transpose X plus B. Just you need to check the sign of that. So you are going to take B, C, E, F. So A you are not going to take, B, C, D you are not going to take, E and F. Okay, so 1001. So 1001. I mean, these are the four values of feature values for which the weights are 1. Okay, so these are the weights. So 1 into 1 is 1, 0 into something is 0, minus 1 into 0 is 0, and 1 into 1 is 1 again, right? B, C, E, F. So I think B, C, E, F, right? 1001. Yes. So basically it will be 2, which is the sign of this is greater than 0. So that's why it will be predicted as plus 1. Okay. So that's the easy question. It will be predicted as plus 1. Output is plus 1. Just a second. Why they are getting 3? Because of the bias. Okay. Because there is a bias also, which is plus 1. Bias will be obviously plus 1. Then one more plus 1 because of bias. This is because of the bias. So finally it will be 3. Okay. Which is greater than 0. So answer is plus 1. It was a good question. Just to let you know that in the decision tree at the leaf, we can use any classifier. Okay. Any classifier, any regressor we can use. It's not necessary you have to use majority voting or something. Okay. At the leaf, you can use any classifier of your choice. Now let's see this question. This was interesting question. Here in this question, they are saying that you have the points, set of points which is 2 power 0, 2 power 1, like that, where each point lies on the real number line at its corresponding numerical value. So which means the first point is 2 power 0, second point is like this, right? So the points are basically one is 2 power 0, another one is 2 power 1. Now this is 2 power 2. And since it is exponential, the distance will keep on increasing actually. Okay. So there will be 2 power 4. Okay. I mean, the distance between the first two could be, this is 2 and this is 1. This is 1. This is 4 and 1. This is 3 distance. Then this is 8 and 4. This is 4 distance. This is 16 and 8. This is 8 distance or something like this. I mean, distance will be basically keep on increasing. Anyway, so basically you have these points. Then distance means Euclidean distance. Okay. Distance is also basically subjective. Now Euclidean distance will be keep on increasing, and there is something called ratio based distance. Now they are saying that you let basically you apply hierarchical clustering and let TSL, TCL, and TAL denote the hierarchical clustering trees obtained using single link, complete link, and average link methods under a given distance function. Okay, so which of the following are correct under Euclidean distance, whether all are equal or something like this? So that's what they're asking, right? See, let me first remind you that single linkage means that if we are merging two clusters, okay, if clusters had more than one point, then single linkage means you are finding out the minimum distance. Or you will take the cluster where you will find out the closest 2 points. I mean, the distance means here the closest 2 points. Complete linkage means distance means that the farthest 2 points. Okay, so in complete linkage, you take the distance between farthest 2 points and you minimize this, which means if you want to check whether, let's suppose there is one more cluster, okay, if you want to check whether you are going to merge these two or you are going to merge, let's suppose these two or something else, then you will check the distance between this farthest point, and whichever is the minimum farthest, you will take that in the complete linkage. Okay, so here first, keeping this distance notation, which means keeping this Euclidean distance. Now tell me in the single linkage what will happen. Single linkage is saying just merge whatever is the closest, so these are the closest, right? And then can you tell me what is the next closest? So currently these are the closest. Now you will merge these two, right? You will merge these two. Now this distance is 3 and this distance is 4. So obviously you will merge this. And then obviously this will get merged with the left hand side only, right? With this cluster. So you will be getting some figure like this, right? You will be keep on merging like this, right? So this is called single linkage. What about in the Euclidean distance only? What about complete linkage? Okay, suppose I ask you complete linkage. Then first obviously you have to merge these two because this is the minimum. Now this will say that okay, let me find out the distance between this cluster. This cluster distance will be basically distance from 2 power 0, right? Which is actually 4 minus 1, right? 4 minus 1, it is 3 only. Sorry, it was 4 minus 2, it was 2. Here it was 2. Okay, 1, 2, 4, 8. Right? So anyway, so it was 2. Sorry about it. Now, so basically this distance is 4, right? For this, now this distance, see, you are not going to check this distance in this complete linkage case, but even if you check this distance, then also this is 3 only, which is lesser than 4, so it will get merged with this, right? Now for this you will say that okay, this distance is actually 8, and then this distance is how much? This is just 7. Okay, so it will get merged with this. Actually the adjacent will be even the this right hand side will be even bigger. Okay, why? Because you are basically multiplying, I mean here you are multiplying by 2. Okay, and here you are not even dividing by 2 properly, which means, sorry, I mean to say that here the distance will be 2 power 3. Okay, I mean here since you are this is 2 power 3 multiplied by 2, which means the distance will be 2 power 3. But here the distance is not exactly 2 power 3. I mean here if you start from 0, then the distance is 2 power 3. But you're already starting from 1, right? So since you're already starting from 1, so that's why distance will be 2 power 3 minus 1. Okay, so that's why this will get merged with this. Similarly, here the distance, okay, the next will be the distance will be 2 power 4 because it will 2 power 5 and 2 power, see, 2 power k plus 1 and 2 power k distance is actually 2 power k. Okay, I mean the distance between these two adjacent will be 2 power k. So between 2 power 5 and 2 power 4, the distance will be 2 power 4. No, distance between these two will be 2 power 4, right? But if you check the distance from here to even this, okay, even this, it will be 2 power 4 minus 1. So that's why you will say this. I mean this will get merged with this. So in complete linkage, this will happen. And the same thing will happen in the average linkage. Average linkage is generally same as the complete linkage, where in I mean in complete linkage you take directly the farthest point. In average linkage also generally this distance dominate. Okay, so average linkage and complete linkage are same here. So basically, in all the cases, you are going to merge with the left, left, left. So you are going to get this in if this is Euclidean distance. Okay. In case if it is Euclidean distance, you are going to get this. But there is one more distance notation which is given in the question. This is called ratio based distance. Okay. So let me tell you that what is this distance. Okay. So let's just see how this distance will behave. Now this is saying I'm going to take I'm going to take, let's suppose these are the 2 points, 2 power a, comma 2 power b. It is saying, or 2 power I, comma 2 power j. I'm going to take something like this. Distance between these two will be maximum of distance, basically maximum of 2 power I, comma 2 power j, divided by minimum of 2 power I, comma 2 power j. So whatever is the maximum, okay. So let's suppose 2 power j is the maximum, or whatever is the minimum, other person will be the minimum. So it will be basically 2 power j minus I, right? If I is the maximum, then this will be I minus j, right? So basically, ultimately, this distance will come out to be 2 power I minus j or j minus I, right? Something like this. So this ratio based distance is nothing but 2 power I minus j mod. Okay. So now if I ask you, suppose in this kind of case, right? So these are the Euclidean distance which I have written. But suppose if I ask you what is the distance between these two, the adjacent. So you will say that, okay, let me take the, let me just take the ratio. So 2 power 4 divided by 2 power 3, or 2 power 3 divided by 2 power 4 doesn't matter. I mean 2 power 4 divided by 2 power 3, because maximum will be above and then minimum. Doesn't matter, basically it will be 2 power I minus j. So which will be 2. Okay. Now distance here is also 2. Distance here is also 2. Distance here is also 2. Okay. So here the distances of 1, 3, 4, 8, this, sorry, 1, 2, 4, 8, these distance, these won't be the distances. The distances will be 2, 2, 2. I mean, adjacent distances will be 2, 2, 2 only. Right? So in this case, if we are using the ratio based, then adjacent distance will be 2, 2, 2, 2, 2 only. Okay. So this is the Euclidean based distance, but in case of ratio based, the adjacent distance will be 2, 2, 2. Now single linkage will say, okay, let me remove this so that you don't have any confusion. Single linkage will say, let me just merge, okay, the minimum. So minimum, I mean, this is 2. Now, since this is also 2, so you can get this, right, in the next iteration, or you can get this also, because this is also 2, right? So you can get this or you can get this, right? It depends on how you are implementing the algorithm, right? So you can get this also. Generally, like, let's suppose we are considering from the left, so you can get this. Otherwise, you can consider from anywhere. Okay, you can get this also, right? So you can get this, or you can get some mix and match. I mean, this, I mean, 4 clusters like this, and then let's suppose there is some point and there are 2 points, then it can go with this, it can go with this, something like this. So basically, since every of this is 2 only, so you can get like the balanced kind of thing, or you can get the previous thing, which is like this. I mean, this distance and this distance is 2, so let's just merge with this, let's just merge with this, let's just merge with this. So basically, you can get something like this also, or you can get something like this. I mean, balanced kind of thing, right? Because every distance is 2, right? Now if you want to merge these two, so this distance is also 2 in the single linkage, so you can merge this two, right? Or maybe you can merge this first. So it depends, right, how you are implementing the algorithm, but you will be getting something like this. Okay. What about the complete linkage in this case? In case of ratio based distance, what will be the complete linkage? It will be little more interesting. Okay. Complete linkage will be getting the balanced kind of tree. Why? Let me tell you. See, complete linkage will find out the distance from the farthest point. See, initially you can merge any two, that's fine. Now for this, the farthest point is this, right? Now here the ratio will be obviously more than 2, and here the ratio is just 2. So that's why you will be just always with a single, I mean, you will be first pairing up 2, 2, okay? First 2, 2. Because for this, if you want to merge, see, for this, if you want to merge, then obviously it should not be merged with this, because this is ratio is more than 2. Here the ratio is 2, right? Now for this, if you want to merge, obviously you want to be merging with this, because here this and this, the ratio is more than 2. So you will be first making 2 to pair, right? And then like this, right? Then like this. Okay. So basically it will be perfectly balanced, which means then in the next iteration this, and then obviously this won't go with this, right? Why? Because the farthest here is 2 power 0, but this will go with this, the farthest will be lesser than 2 power 0, right? So basically there are only, I think, 1, 2, okay, 1, 2, 3 are coming in between, but here 1, 2, 3, and then this is the fourth one, okay, and this is the third one. So basically you will be just merging 2, 2. It will be perfectly balanced. Okay. So in case of complete linkage, it will be perfectly balanced. And this will be the same with the average linkage also. So average linkage is not easy to find out, but it is mostly behave like the complete linkage. Okay. So you can say that in case of single, if in case of ratio based, the single linkage could be anything, right? Could be like this, could be like this, but complete linkage will be the perfectly balanced. So so in Euclidean distance, all are same. Okay, all are same. But in case of ratio based, okay, complete and average will be balanced. Complete and average will be balanced. And single linkage could be like this, could be like other also, right? So maybe like this, or maybe not equal to this, maybe equal to this. Okay, depends on the implementation. But complete and average will be same. So in Euclidean distance, everything will be same. Under Euclidean distance, everything is same. So A is the answer. Under ratio based, these two will be same. Okay, this is guaranteed, right? So C is the answer, right? Which of the following statements are correct? So this is correct. Okay, I mean this may or may not happen. So you can say that it depends on the implementation. Maybe not equal to also. Okay, great. Okay, now let's move to the next question. So let's see this question. This question was related to stochastic gradient descent method. So what this question is saying, let me just try to tell you. Okay. So this is saying that you have some loss function, regularized loss function, and then uh, you are using the learning rate, but the learning rate is basically changing with every iteration. They are saying that note that the learning rate keeps on changing at every iteration because it is depending on t. Assume that the initial parameter w1 is 0, okay, at the gradient. So basically they are asking wt plus 1 update rule. So as you know that you have to go in the direction of negative gradient, which means negative gradient, this is the direction where you should be going, right? So this is very popular update rule, right? This is update rule for the gradient descent. Now, if it is stochastic, then in that case, you will be basically having the differentiation. But for loss function will be just one example. Okay. So by the way, for just one of the example, what will the loss function? If you differentiate this, then this will be gradient of LW, right? Gradient of LW, GT due to the gradient of the loss computed using the current example. So basically, this is nothing but GT. Anyway, plus 2 2 into W 2 lambda by 2. So basically it will be W into lambda, right? So basically this is GT. They are saying using the current iteration, GT is given like this plus W lambda. So let me write. So basically it will be WT plus 1 equal to minus eta GT plus lambda W. Okay. So it will be your update rule. Now, I mean W means WT. Okay. Now if you notice that this particular update rule, okay, this is the stochastic update rule, but let's just see the options whether this particular update rule is matching with any of the options. Now, if you notice in option B, okay, for option B, this is almost same. This particular update rule is almost same for option B, but here it is plus, but here it is minus. So that's why option B is wrong. Okay, option B is not correct. Option B is wrong because of the plus, and this is minus, right? So option B is wrong, and this is plus. Now, the other obviously option A seems to be wrong. Now, these options are basically some summation. These are including summation, and these are not including WT. So basically, this is called unrolling. Okay, so you have to unroll this, and then you have to see that which option is correct, right? So what we can do, we can basically take the WT terms at together. So it will be WT1 minus you can say eta lambda into WT, right? Minus eta GT. So eta is already given, learning rate is already given to you, 1 upon lambda t. Okay. So basically, you can even substitute this. It will be WT plus 1 will be 1 minus 1 upon lambda t into lambda wt minus 1 upon lambda t into gt. Okay. Now lambda will get cancelled out. So let me write wt plus 1 finally. That we are getting is 1 minus 1 upon t, right, into wt minus 1 upon lambda into t into gt, right? So this is wt plus 1. Now it is given, okay, if you see the question, it is given that w1 is actually 0. I mean, the first weight is 0, right? So w1 is 0 is given to us. Okay. Now what about W2? W2 will be, since this will be W1 t equal to 1, so it will be 0 equal to minus 1 upon t equal to 1, right? G1, something like this. What about W3? W3 will be W2. W2 is this, right? So this is 1 minus 1 upon t into W2. W2 is 1 minus 1 upon lambda G1 minus 1 upon lambda 2 lambda into G2, right? Something like this. And I think T was, for this T is basically 2. So T is 2 already. So you can write 2 here. Okay. Now if you solve this, W3 you will be getting something like this. Okay. Minus 1 upon 2 lambda. Minus 1 upon 2 lambda. G1 plus G2. Okay. W2 you were getting minus 1 upon lambda G1. Now you are getting minus 1. Basically it's kind of, I think this is kind of average. Okay, lambda is at the denominator. It's kind of average. Okay, I mean basically taking the average of all of this. So which means I can say W4 must be something like this. It will be G1 plus G2 plus G3 divided by 1 upon 3 lambda minus, right, taking the average of these three, and then multiplying by minus 1 upon lambda, something like this. Now can you write Wn here? Okay, with this pattern you should be able to write Wt plus 1. I think they're asking. This should be minus 1 upon t lambda and then summation of all gi, where I is equal to 1 to t, something like this, right? So let's just see what is the answer. Yes, this is correct. So which means C is the correct answer, right? I mean, instead of lambda t, you can again replace eta t. So C is the correct answer here. This was a good question. It was basically related to that whether you are able to unroll or not. Okay, related to this. So yes, C is the correct answer. I think the same kind of thing we have done in perceptron. Whenever we were learning the perceptron, at that time the derivation and those things that involve the unrolling and all. So you can just revise the perceptron derivation, and then probably you will be able to see something like this, right? Okay. Now let's solve this question. So here, this question was related to PCA, and then they're asking some things about the PCA. They're saying, suppose that we sample S from this distribution. Okay, there is like multivariate distribution here. This is a covariance matrix. Okay, this will be covariance matrix. And there are new data point which is X equal to WS. Then what is the distribution of X? So basically, as we know that if we want to find out, basically we have to find out in the PCA. As we know, the covariance will be something like this. Okay, I will just prove it in a second, but the covariance matrix will be something like this. Okay, if sigma was the earlier covariance matrix and the mean will be anyway 0. So let's just find out the mean. Basically, the mean of the new point, which is, let me write X. It is same as expectation of ws, right? W is some matrix which is constant matrix. It is not a random variable or it is not our data. So it will be basically W into expectation of s Expectation of s is given to be 0. The mean is given to be 0. So that's why if the earlier the data was centered, then after projection also the data is centered, right? I mean, this is very well known fact. Now we can also find out the covariance, right? So, but before finding out the covariance, let me just remind you one formula that we have seen, which was, see, which was something like this. Yeah. So basically, there is a formula of expectation of xy and covariance. I mean, it relates like this. So if you want to find out, if you want to find out expectation of w into, sorry, the covariance you want to find out, right? So basically, you want to find out the covariance of this x. So you can use the similar formula. So basically, let me just tell you what you can do. So expectation we have found out, it will be 0, right? So covariance of x comma x, or it is same as the variance of x. Okay, it doesn't matter. So basically here the same formula we can use, which means if you want to find out the covariance, it will be expectation of xy minus expectation of x into expectation of y. So it will be something like this, right? Okay. Now this term is 0. Okay. And then the covariance will be just like this. And then if you put the value of x, which is ws, then you will be getting this is the earlier covariance matrix. Okay. You will be getting sigma here. This will be w sigma w transpose. It is the very well known fact that if you want to find out the covariance matrix for the projected data, then it will be w sigma w transpose. Okay. So where this sigma was the covariance of earlier data, right? We have done this multiple times in the class also. So basically, finally, you can say that the projected data will be following this distribution. Okay. Now let's see this question. This question was a nice question, and it was related to whether you understand TPR, FPR meaning. Okay. So they are saying that true positive rate and false positive rate are given, and total number of negative and total number of positive are also given. You need to find out the accuracy. So basically, the accuracy is total negative, right, and total positive. You need to divide by that, and here you need to tell how many are correctly classified, right? Correctly classified, total correctly classified. So you can say total correctly classified, right? Now TPR, which is a true positive rate, it means let me write total. You know, so this is total positives. Out of these total positives, how many are actually truly positive, right? So this is basically model correctly predicted positives. Okay. See, you need to know how many, for to find out the accuracy, you need to know how many model correctly predicted positives plus how many model correctly predicted negatives, right? So currently we know how many model correctly predicted positives will be actually nothing but, so basically this number, model correctly predicted positives, this number will be, this is basically n positive, it is given like this is n positive into TPR. Okay, this is what you know, but you have to also calculate the other thing, which is how many model correctly predicted negatives. Okay, so which you can find out using FPR. So FPR is also given, okay, which is given by FPR, which is basically false positive rate, right? This is false positive rate. So it is saying out of out of all uh, positives, right? sorry, out of all negatives, out of all total negatives, you can say total negatives, which you have given the false positive, total negative. Okay, which you have given the which you have given the positives. So basically, model incorrectly given positives. Okay, out of all total negatives, how many model incorrectly given positives? Right. So let's suppose these are the total negatives, and some of them are model incorrectly given positives. Okay, these are the total negatives. Then, 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 how many model correctly given negatives are these? Right. So basically, let me tell you, if you find out one minus FPR, okay, if you find out one minus FPR, it will be, it will be total negatives. That's fine. Here you will find, you will be writing model correctly given negatives. Okay, model correctly negatives, right? And that's what we wanted, model correctly negatives, correctly predicted negatives. This number will be, this is n negative, right? So this number will be n negative into 1 minus FPR. So you can say this will be n negative into 1 minus FPR. Okay. Now I know both of these numbers, so you can just take the summation divided by n positive plus n negative. So which means accuracy will be, okay. So the accuracy will be how many model correctly predicted positives plus how many model correctly predicted negatives, which means the first term plus how many model correctly predicted negatives divided by total negatives and total positives, right? So this is the accuracy. So that's why you can say uh, which option is correct. Okay, A is correct here, right? It was good question. It was testing your TPR and FPR concept. It was a good question, right? Okay. Now let's just move to the next question. Yeah, let's see this question. This question was saying that you have some y and x1 to xn. You are summing up from x1 to xn, right? Now, what is the expected value of ey? So that's what they are asking. So basically, they are saying that y is summation of some random variables, but the number of random variables are also basically not fixed. It is also the random variable. They are asking the what is the expected value of y, right? It is basically, you can say, it is basically you know, if this n could have been fixed, right, then it could be like, let's suppose the x1 and each are independent and these are having the same expected values. If the n is fixed, then the answer will be directly like this. Okay, answer will be directly like this if n is fixed. But here the n is also the random variable. So in that case, the expected value of the sum is basically, intuitively I'm telling you, okay, obviously mathematically we will prove, but intuitively I'm telling you the expected value of sum will be expected number of terms, because here currently it is also not fixed. So that's why expected number of terms into expected value of each term. So expected number of terms, which means expectation of n is 4 and expectation of each term is 2. So that's why 8 is the correct answer here. Okay, but we can solve it mathematically also. So basically here we want to find out the expectation of y, right? Intuitively, I hope you are able to understand that what I'm saying. But let's find out mathematically. Since it will depend on the n, right? So you can use this formula of total expectation, which says that if you want to find out expectation of y, which will be same as expectation of y given n, right? Now let's just find out expectation of y given n. It is same as expectation of x1 plus x2 xn given n, right? Now, given n, they are saying that these are actually independent, right? Let n be the position variable. So these are anyway independent normal random variables, right? So given n also obviously they are independent only. So which means this will be same as expectation of x1 plus expectation of x2 like this, right? Expectation of xn. So expectation of 1 is 2. Since there are n, so it will be n into 2. So it is 2n basically. Okay. So inner quantity, okay. So this quantity is coming out to be 2n. Now you can say expectation of 2n, right? Which is 2 into expectation of n. And for the Poisson distribution, the expectation is just lambda, right? Uh, they are giving, okay, they are directly giving the expectation which is 4. So which is 2 into 4, which is 8. So this 8 is the correct answer. It is again same as expectation of n into expectation of x, which is coming out to be 2. Expectation of x is 2 only. Understood? So 8 is the correct answer here. So basically, if you want to find out the expectation of y, then you can condition on n and then you can find it out. Right? See here that you can condition on n and then you can find it out. Or intuitively, you can also think that if you want to find out the expected value of the summation, then it will be expected number of terms into expected value of each term. Right? Now, this question was also in the similar terms, okay, where you might have to apply the conditional expectation formula. Okay, so they are saying like x with a random variable which is uniformly distributed on 0 1. So x is uniformly distributed on 0 1. Now suppose that given x, the random variable y, given x, okay, given x, this is uniformly distributed on 0 comma x. Okay, I mean if x is 3, then it will be 0 comma 3 like this, right? If x is 4, it will be 0 comma 4. Now given x and y, the random variable z, given x and y, this is uniformly distributed between y comma 1. Okay. Now they're asking what is the value of expectation of z. Okay. So basically, x is uniformly distributed between 0 comma 1. Y is uniformly distributed given x. Basically, you can say it is uniformly distributed between 0 comma x, and z is uniformly distributed between y comma 1. They're asking expectation of z, right? Obviously, here, since you can't find expectation of z directly because this is depending on x and y, so you can use a similar kind of formula: expectation of z given x comma y, right? And since this z given x comma y is uniformly distributed between y and 1, so what is this expectation? See, we want to find out the expectation of z. So we can use this formula, right? So it is just like a total expectation. See here that for the uniform random variable, by the way, the expectation is a plus b by 2, right? So we can use the similar uniform random variable formula. But given this, as we know that this particular random variable, like z given x and y, this is a uniform distribution. So that's why this expectation is 1 plus y by 2. So basically you can directly say expectation of 1 plus y by 2. Okay. So ultimately, expectation of z is nothing but expectation of 1 plus y by 2, which is nothing but expectation of 1 by 2 plus y by 2, which is nothing but 1 by 2 plus expectation of y 2. So you need to find out the expectation of y. Now, again, to find out the expectation of y, you can use a similar kind of thing because it is depending on x, right? So expectation of y will be expectation of y given x, right? So expectation of y given x is again a uniform random variable. So it will be 0 plus x y2. So it is expectation of x y2. Expectation of x is basically 0 plus 1 by 2, right? So it is 1 by 2 into 1 by 2, which is 1 by 4. Expectation of y is coming out to be 1 by 4. So that's why it will be 1 by 2 plus 1 by 8. So it will be 5 by 8, right? So 5 by 8 is the correct answer here. This was very good question. I hope you are able to understand these kind of questions now. C is the correct answer here. Okay. Now let's solve the next question, which is this one. Now in this question, they're asking probability of by less than 1 given x equal to 3. So you can directly use the base formula, which is by less than 1 comma x equal to 3 divided by probability of x equal to 3. So the joint probability is given to you, right? Joint probability distribution is given to you. Now, if you want to find out by less than 1 comma x equal to 3, so you can put x equal to 3, but for by, you have to integrate, right? So basically, this will be integration. For the by, you have to integrate from 0 to 1, and for x equal to 3, you can directly put 1 upon 2 y square e power minus 3 dy, right? Divided by this thing. For this, you have to marginalize. Marginalize means integrate over all the possible values of y. Okay. So, and then you can directly put x equal to 3. So if x is 3, then y will be basically running from 0 to 3, right? So 0 to 3, the same thing, 1 by 2 y square e power minus 3 dy. Okay. I mean, both are the same integration, but the limits will be different. Okay. The limits will be different. So let's just see the answer. So yeah, this is 0 to 1 limit. Okay. 0 to 1 limit. And this is next will be mm, mm, mm. Yeah, x is 3. So it will be basically 0 to 3 limit. Okay. So if you solve this, uh, yeah, this is 0 to 3 limit, right? The same things, just 0 to 1 limit and 0 to 3 limit. If you solve this, then you will be getting 1 upon 27. Okay. So it is 1 upon 27. It was easy but nice question. I mean, not that much easy. Probably like students are not able to convert that to the limits. But yes, once you convert that to the limit, then it will be easy question. Now let's solve this question. Here in this question, they are asking expectation of x. Expectation of x will be uh, for any random variable, it will be basically if it is continuous or it is basically discrete, it will depend on that. But it will be basically integration of x fx, if fx is the probability density function, right? And then it will be all the values of x, okay, over all the values of x. Now first we need to find out the small fx, which means from this cumulative distribution function we need to find out the probability density function. Okay. So what it will be, since these are the ranges, okay, these are not x equal to 1 to x equal to like 1 comma 2 like this. So it is basically the continuous random variable. If you differentiate, okay, then you will be getting this. So there is 1 by 8 if x is between 0 to 2. It will be 2x x by 8 basically, x by 8 if x is between 2 to 4. Otherwise, if you differentiate this, this will be 0 and this is also 0. So x is less than 0 or greater than 4, it is 0. You can say otherwise. So you will be getting fx something like this, right? Then you need to just just integrate this, and then the limits will be 0 to 2, it will be 1 by 8, and then 2 to 4, it will be x by 8. Okay. So by the way, we generally don't put the equality sign in after the differentiation. Okay. So after the differentiation, basically it doesn't matter because this is a contiguous case, but generally we don't put. Okay. Or maybe you can put. Okay. Doesn't matter. So 31 divided by 12 will be the answer. Now let's see this question. This was also a good question. So what this is saying, this was a probability question. They are saying that you can choose either vendor V1 or you can choose vendor V2 with equal probabilities, which means 1 by 2 probability here, 1 by 2 probability here. Then if you choose V1 vendor, then it is possible that that you can get lifetime of the laptop maybe greater than 2. Okay, let's suppose X is the lifetime. Maybe it is greater than 2 or maybe it is less than 2. Okay. Similarly, here also the lifetime could be greater than 2 or lifetime could be lesser than 2. Okay. X is the lifetime of the laptop, right? Now they are saying that that V1, this if you choose the vendor one, then it follows a uniform distribution from 0 to 4. Okay, so uniform distribution, if that is the lifetime will follow the uniform distribution of 0 to 4, which means greater than 2, basically less than 2 and greater than 2 will be having the equal probabilities, which means 0 to 4, basically it is exactly middle. So less than 2 and greater than 2 will be with the equal probabilities, which means it will be also 1 by 2, it will be also 1 by 2 probability. If V1 is the vendor, then both the you can say possibilities, which is less than 2 and greater than 2, are with equal probability. Okay, 1 by 2, 1 by 2. But if V2 is a vendor, then it is following exponential distribution. Okay, the lifetime is going to follow exponential distribution. Then can you tell me what is the probability of getting lifetime greater than 2? So if X is following some exponential distribution, then what is the probability of X greater than 2? Basically, there is one standard formula, and the formula is basically if X is greater than T, then in case of exponential distribution, you can directly get the answer e power minus lambda t. Okay, here it will be e power minus 2 lambda. Right, otherwise you can definitely do the integration or something, and then you can find out the formula, or you can use the summation or integration and then you can find out the formula, but here I'm directly using this formula. Okay, so basically here in this case it will be e power minus 2 lambda. The probability will be e power minus 2 lambda. Here the probability is 1 by 2, but here to happen this, basically I should be writing it here e power minus 2 lambda. Okay, to happen this probability is this, obviously 1 minus e power minus 2 lambda. Okay, something like this. Okay, now they are asking that given that the lifetime was greater than 2. Okay, they are saying that given that lifetime was more than 2, then what is the probability it is coming from V2? So basically it is a standard base formula kind of question, or standard tree method kind of question. So here they are asking probability of vendor V2 given that the lifetime was greater than 2. So it is same as probability of V2 and lifetime is greater than 2 upon lifetime is greater than 2. So basically B2 and lifetime is greater than 2, which means multiply by these two things, right? So it will be equal to 1 by 2 into e power minus 2 lambda divided by x greater than 2 means summation of these two, right? 1 by 4 plus 1 by 2 into e power minus 2 lambda. Okay, so this is how you are going to solve this. If you solve this, 2 upon 2 plus e will be the answer. Okay, you can use the tree method. You can use this tree method. So which means if you match the options, then A will be the correct answer, right? 2 upon 2 plus C. Now let's go to this question here. they're asking rank and nullity of this matrix. Okay, so what will the matrix with respect to the standard basis of this linear transformation? As you know, the matrix will be T of E1, T of E2, T of E3, right? This will be the matrix where E1, E2, E3 are the standard basis vectors, which means E1 is 1 0 0, it will be 0 1 0, it will be 1 1 0. Okay, sorry, 1 0 0 1. Okay, so these are the standard basis vectors. You can do this, or you can directly basically use the shortcut, which is like this. If you want to find out the matrix associated with this linear transformation, standard matrix, then it will be okay. X plus y, like row wise, you can write x and y are 1 1. This is 0. Y and z are 1 1. This is 0. Z and x and z are 1 1. This is 0. Which means if you multiply by the x, y, z, you will be 100% getting this, which is basically x plus y plus z, and z plus x. Okay. So this is the standard basis matrix. Now they're just asking you to find out the rank and nullity for this matrix. You can do the simple, actually you can find out the determinant, and here the determinant is coming out to be non-zero, so rank is 3, right? And also without the determinant also, you can see that, see, if this is 0, right, and then others are not 0, so which means that this is linearly independent of others. This is 0, others are not 0, this is also linearly independent of others, this is also linearly independent of others, so rank is 3 only, right? And hence nullity is 0. It was a simple question only, right? Rank is 3 and nullity is 0, so D is the correct answer. Now let's solve this question. This was also easy question. Let's see what they are saying. So see, in this question, they are saying that every vector after 3 are basically summation of the earlier two vectors. So which means only x1 and x2 are the free vectors which we can choose anything. And then x3 will be basically summation of these two, and x4 will be summation of x3 and x2 and so on. So x3 onwards, these are dependent. These are only linearly independent. At max, we can choose, right? So what is the dimension? Only 2. Dimension will be 2. That's very simple question. Okay. Completely determined by the free choices of x1 and x2. So dimension will be 2. Now, let's solve this question. So in this question, they are saying, suppose mx equal to b, okay? And then they are saying, what is the value of x transpose b? So basically, x transpose b means mx. Let me tell you that this M is basically a skew symmetric matrix. Okay, you can easily observe that it is skew symmetric, right? M is skew symmetric matrix. And for any skew symmetric matrix, this value is 0. Why? Okay, for, let me write, for any, why that is the case? Because see, this is a scalar, right? I mean, mx is one vector, and then this dot product is actually scalar. So since this is scalar, you can write like this. This is equal to the same as its transpose, because this is scalar, which means which means let me change the pen color. This is x transpose m transpose x, right? And m transpose is minus m transpose is nothing but minus x transpose. So a quantity cannot be same as negative of the same quantity, which means the quantity has to be 0, right? So from here you can say this is 0. Okay. This is one property of skew symmetric matrix. Okay. That x transpose mx will be 0. This is very nice property, and this x transpose mx for any positive definite, this is actually greater than 0. For negative definite, it is less than 0. But for skew symmetric, this is 0. Okay. So answer is 0. Now let's solve this question. We have given this question to for some purpose, basically to tell you one important thing about the matrices. See, suppose I ask you what is this mx, then suppose x is eigenvector. Okay, suppose x is eigenvector. In this case, you will say it is lambda x. If I ask you what is m into mx, which is m square x, then you will say it is lambda square x. What is m cube x? Then you will say it is lambda cube x, something like this, right? Now, suppose I say that what is m power nx, then you will say this is lambda power nx. Now, suppose lambda is less than 1. Then, if you keep on raising the power, then ultimately this will go to 0, right? If lambda is less than 1. If lambda is greater than 1, then this will explode, right? I mean, this lambda power n will be too much if n tends to infinity. If lambda is less than 1, then this will vanish. If lambda is equal to 1, then this will stay constant, it will be x only. Okay, for lambda equal to 1. If lambda is less than 1. If lambda is greater than 1, then it will actually explode. Okay, so you can say this value will be like kind of infinity if lambda is greater than 1, right? See, if x is eigenvector, then finding out this limit was very easy, right? If x is eigenvector, it depends on the corresponding eigenvalue. But here, this x is actually not eigenvector. So if x is not eigenvector, then what we can do? The eigenvalues we know, right? We can find out the eigenvectors, and then we can represent x as linear combination of the eigenvectors. Okay, some linear combination of the eigenvectors. Okay, so how it will help you? Let me first tell you. See, you can find out the eigenvectors using the eigenvalues. Eigenvalues are very easy here, 1 by 2 and 1, right? So these are the two eigenvalues. Now let me find out the eigenvectors and let me write the x as, okay. So yes. So basically, let's suppose x is basically coming out to be u plus 2w, where u and w are the eigenvectors. U is eigenvector corresponding to 1 by 2. W is eigenvector corresponding to 1. Okay, these are the eigenvectors and eigenvalues. See, finding out the eigenvector is also easy, and then eigenvalues are already known to us. Then we need to find out that what is the linear combination. This you can solve system of linear equation. I mean, if you want to find out what is this a and b, right? So you can solve this system of linear equation to find out the a and b. Okay. So basically, assume that finally we got this, and they are asking m power n x, right? So if you tell me what is this mx, then it will be mu plus 2 mw, which will be same as mu means 1 by 2, it will be lambda x, right? 1 by 2 u plus 2 into mw means or maybe instead of u and w, let me use mm, x1 x2 for the eigenvectors. What could be the better notation? E1 e2. I mean, even e2 don't get confused with the standard basis, but yeah, these are the eigenvectors. Okay, or maybe you may get confused, I'm not sure. So maybe let me just use u and w only. Okay, so mw will be basically 1 into w. Okay, but it will be w only. So if you keep on raising the power m power nx, then it will be 1 by 2 power n u plus 2 into 1 power n w. Okay, something like this. Okay, now if n is infinity, this will vanish, but this will be same. So finally the answer will be 2w. Basically, it is saying that if you keep on raising the power, then if the eigenvalue is less than 1, then this particular component will vanish. If the eigenvalue is exactly 1, then that component will stay. Okay, or if it is greater than 1, then that component will explode. So 2w, and w is basically, we already know the eigenvector, so that's why w is this, which is 1 2. So 2 4 will be the final answer. Okay, so 2w, which means 2 4. So basically, m into x will be something like this. Okay, m into, you can write this x as c1 v1 plus c2 v2, something like this, where v1 v2 are the eigenvectors. Now you can check the behavior. Now if you keep on multiplying, okay, so this will be C1 into MV1 plus C2 into MV2, which is same as C1 into lambda 1 V1 plus C2 into lambda 2 V2, right? Now if you keep on multiplying, it will be basically C1 into lambda 1 power n V1 plus C2 into lambda 2 power n V2. Okay. Now, depending on lambda 1, lambda 2, it will either vanish, explode, or it will be basically remaining just same. If lambda 1 is 1, then the power won't matter. Okay. So that's how basically any vector behaves if we keep on multiplying with the matrix. Okay. It will depend on the eigenvalue. Okay. This vector, the component of this vector, along with the eigenvalue, which is basically, if less than one, then along with that particular eigenvector, if the eigenvalue is less than one, then that particular component will vanish. Okay. Now let's see this question. This was easy question only. Here in this question, they are saying that E1, E2, E3 are the standard basis, right? So if they're standard basis vectors, then M E1 you can say is the first column of M, first column of M. M E2 is basically second column of M, and so on. So they're just asking if rank is 1, then first and second column are linearly independent. It is obviously not possible. If rank is 2, then it is guaranteed that first and second. See, two are linearly independent, but we don't know which two. So that's why this is wrong and this is also wrong because we don't know which two. But if rank is 3, then obviously 3 are linearly independent. So this is also linearly independent, right? So that's why D is the correct answer here. If rank is 2, then exactly two columns of M are linearly independent, but we cannot guarantee that they are specifically ME1, ME2, or ME1 and ME3, right? Which means first, second, or first and third. We don't know like which two. Just by looking at rank, we can't say that which two are linearly independent. So that's why D is the correct answer here. So now let's see this question. So this was related to calculus. So in this question, they are saying that f is one differentiable function, okay, from this 0 to 4 to the real numbers. Now f0 and f2 are given, and similarly f4 is also given. And then they're asking something about f dash x1, where x1 is either from 0 to 2, or it could be from 0 to 4 also, or 2 to 4 also. So this question is clearly indicating that we need to apply mean value theorem, because here the x1 is belonging to some range, and then they are asking f dash x1, right? This is a clear indication of mean value theorem. So how to solve this question? You can apply MVT between these 2 points, which is 0 and 2, and then between 2 and 4. So let's just quickly do it. So basically, between 0 and 2, if you apply, then let's suppose x1 is belonging to 0 to 2, right? Then f dash x1 must be f of 2 minus f. I mean, there must exist some x1, which is basically from 0 to 2, and which will follow f dash x1 equal to like this, right? So f2 is given to be 2, f0 is given to be 1, so it will be 1 by 2, right? So there must exist x1 in this range such that this happen. So option is saying there does not exist x1. Obviously option A is wrong, right? What about option B? Option B is saying there exist x2 and x3 such that in like both are equal, right? So uh see, let me just apply mean value theorem, okay, between 0 to 2 for x2. So let's suppose there is x2 between 0 to 2, then I mean this is the same as the previous thing. So f dash x2 must be equal to f of 2 minus f of 0 divided by 2 minus 0, right? So which will be f of 2 is here given to be 2, so it is 2 minus 1 divided by 2 minus 0, which is 1 by 2. Similarly, you can find out x3 from the range of 2 to 4, and it will be f dash x3 divided equal to, this will be equal to, let me write this here. f of 3, sorry, f of 4 minus f of 2 divided by 4 minus 2. So f of 4 is given to be 3. So 3 minus 2 divided by 2. So this is also 1 by 2. So yes, there exists some x2 which is f of, where in this range that f dash x2 is also 1 by 2 and f dash x3 is also 1 by 2. So yes, so basically there are x2 and x3 such that both are equal and both are equal to 1 by 2. So that's why B is correct. What about option C and option D? So actually, we cannot say anything about the double differentiation. Okay, from this given information, we cannot say anything about the double differentiation. So C and D are the wrong. So B is correct. Okay, so that's how you can solve this question, and correct option is B. Now let's solve this question. So in this question, they are saying that there is some C in some interval 0 to 1 such that this C is greater than fx for all x, which means this is a clear indication of saying that fc is maxima and f0 is also maxima. I mean, there could be two maxima, right? F0 is also maxima because this is actually exactly equal to fc. Okay, so since fc is maxima, so f dash c must be 0, right? What about at 0 how the function will behave? Okay, this is more important than C. I mean, C is straightforward, so either A and B is the answer, or maybe A, B and D are the answers. But what about the function differentiation will behave at 0? See, they are saying that f0 is maxima, right? Which means in the neighborhood the function should decrease only, because it is a maxima, right? If this is maxima, then in the neighborhood function should decrease only. So the differentiation is basically defined for 0 plus only, and they're just writing f dash 0, which is fine. But the function should decrease, which means it is either decrease or remain constant. Either decrease or remain constant. I mean, there could be like multiple maximas, that's fine. Okay, but either decrease or remain constant. It cannot increase because the f0 is the maxima, right? So that's why this is correct. Okay, either decrease or remain constant. So which means B is the correct answer. Okay, since it is maxima, and then we are going to the right. I mean, the function is only defined for the right. Okay, for the right range, and then we are going to the right. So that is why. Just a second. So so you can say that f0 will be the maxima. Since I mean, since f0 is the maxima, so since we are going to the right, so function must decrease, right? Must decrease. So anyway, like B is the correct answer. It was simple question. So correct answer is B. Now let's move to the next question. So this question is saying that you have a graph which is partitioned. Okay, the graph is basically partitioned into two sets, b1 and b2. Vertices are partitioned into two sets, b1 and b2. Now they are saying each vertex v. Okay, so basically you are flipping a coin independently. If the outcome is head, then the vertex is basically going to fall in this v1. If the outcome is tail, then vertex is going to fall into this. Okay, and the probability of head and tail are also given. A coin is biased, so probability of head is 2 by 3, probability of tail is 1 by 3. What is the expected number of edges crossing b1 and b2? Okay, see, when will there will be edge? Tell me, when will there will be edge? The edge will be at the case whenever the vertex. Okay, let's suppose there is some edge ub. Okay, there are two vertices ub. U is here and v is here, or v is here and u is here. Then only there will be the edge. For every edge, you can say for every edge ub, that will be the crossing edge also. I mean, the edge is ub, but that edge will be the crossing edge also. Whenever you can say u is in b1. So what is the probability that u will be in the b1? Anything goes to the b1, which means the probability of head. U is in the b1, and at the same time v is in b2, which means this is the probability. Or u is in v2, and then v is in v1, something like this, right? So basically this is 2 by 9 plus 2 by 9, which is 4 by 9, right? So 4 by 9 is the probability that there will be the edge between, there will be the crossing edge basically. Okay. So with the 4 by 9 probability, there will be the crossing edge. So any edge can be the crossing edge with the 4 by 9 probability. Okay. So you can say that any edge could be crossing edge with 4 by 9 probability, right? Now, since there are E number of total edges, so that's why you can say that 4 by 9 into E, these are total crossing edges. These will be total, or you can say expected crossing edges, right? Expected crossing edges. Okay. So 4 by 9 into E is the correct answer. Expected number of crossing edges. So B is the correct answer. Now let's solve this question. So in this question, they are saying the graph is unipathic. Okay. Which means uh, any two vertices, between any two vertices, there is at most one simple path from U to B. Right. The edge widths, this is a directed graph. Okay. The edge widths may be positive or negative. We wish to compute the shortest path distance from S to all the vertices and report if a negative weight cycle is reachable from S. Okay, that's what we want to do. So by the way, this graph is unipathic, but doesn't it, does this mean that there won't be any cycle? See, from U to B, there is a single path that I agree. Okay, let's suppose this is U, this is B. Okay, there is a single path, but there can be the cycle, right? I mean, there can be definitely a cycle. From, see, this is unipathic, but still there is a cycle, right? From U to B, there is a single path. This is unipathic, still a cycle. Okay. So there is one option, option D. Option D is saying negative weight cycle cannot exist. No, they can exist. So that's why D is wrong, right? Now let's just see the other options. They are saying the standard Bellman-Ford algorithm is required since BFS, DFS cannot detect the negative weight cycles. See, here, if the graph is already unipathic, then since there is only one path between any pair of vertices, that's why, suppose you are starting from any vertex X, right? Now, you apply either DFS or BFS, doesn't matter. Since there is just one path, whatever path they explore, that will be the shortest path only, because since there is just one path, right? So whatever path they explore, that will be shortest only, right? That will be shortest only. Now we just need to check whether there is a negative weight cycle or not, right? I mean, can this DFS BFS also detect negative weight cycle in this particular case? That's the only thing that to remain to check. Okay. So what we can do, we can apply DFS and BFS in a regular fashion, and if we are getting, let's suppose from S, okay, we can update. So from S, we will be having some distance to U. Let's suppose this is stored in DU. Okay, let's suppose this is 5. Now we can whenever we are exploring at that time, whenever we are getting the back edge, or maybe the, I mean, some edge which is basically again leading to U, right? At that time we can just quickly check if that is decreasing the earlier cost, it means that there must be some negative cycle, right? If that is decreasing the earlier cost, because till now from here to here it is 5. Now ultimately it is basically 5 minus something, which means this minus is coming from this cycle, right? So we can easily detect in this case, in this particular specific example, we can easily detect the negative weight cycle using DFS or BFS. Yes, we can apply Bellman-Ford for sure, but it is not required. So option is saying that standard Bellman-Ford is required and DFS cannot do. So that's why this is wrong. Okay. Option B is saying since the graph is unipathic, DFS or VFS can be used to compute the shortest path. Actually, there is just one path, so shortest path is the only path. And negative bit cycle also can be detected if the relaxation improves an already vegetated vertex. Relaxation means updation. Okay, relaxation is basically one term that we use in the shortest path terminology, which is a standard term only. That's why I have used it. So relaxation means updation. Okay, whenever we update any edge, weight, or any distance, we call it relaxing. Okay, we call it relaxation. This is very standard term. We have seen this in Dijkstra algorithm, right? So anyway, B is the correct answer. What about C? Dijkstra algorithm work correctly because the graph has at most one simple. See, if there is a negative weight cycle, so in that case, Dijkstra might not work correctly. Okay. So Dijkstra will not be able to detect because we wish to detect also. Okay, we wish to report the negative weight cycle, but Dijkstra doesn't do it. Okay. So that's why B is the correct answer. It was really a nice question, right? It was really a nice question. So B is the correct answer here. Okay. Now let's see this question. They are saying we maintain a dynamic set D of integers using a binary search tree. Okay, this is BST. Inserting an element into D takes constant time. Each node X requires an additional field. So they basically generally in a tree we have left pointer, data, and right pointer. I mean these are the three fields generally we store, right, in any tree. Now they are saying let's just store one more field, which is basically we will be calling size. Okay, size. And how do we calculate the size? It will be left size plus right size plus one. Okay, and nil nodes have zero size. The operation count d comma x returns the number of elements in d that are strictly larger than x. Okay, so let's suppose you want to find out how many elements are strictly larger than this x. Okay, in in this d. Okay. Starting from the root, the algorithm compares x with the current node key and moves left or right, updating a counter using the stored size value. So basically, you want to know the size of this, right? So basically, you will be going to the left or right depending on the node key. So basically, we want to know number of elements larger than x, right? So what we will be doing, we will be starting from x. So what I think was that's what they are saying. Compare x with the current node key. So basically, what algorithm will do? Algorithm will be basically comparing the current node. Let's suppose this is 5. Okay, and x value is let's suppose this is 3 or something. Algorithm will be comparing this 5 with this 3. If this 3 is lesser, then it will go to the left, right? Because we want to know how many elements which are larger than this 3. Okay, then what we can do, we can take a call like larger than this 3 means we can take a call here. We can go to the left, and obviously all these elements are anyway larger than this 3, and then this will be anyway counted. So we can write some algorithm. That's not a problem, but we will be either going to the left or right. That's what they are saying, right? We don't have to go to the both sides. Now, which of the following is correct? When x is less than the key, adding size of right plus 1 to the counter correctly counts the larger elements. See, if x is lesser than the key, here that's the case, then what will you do? Yes. So size of right plus 1, you will anyway add this to the counter because all of these are anyway greater, and then this is also greater, right? So yes, this is correct. So this A is correct here, right? I mean there are multiple options which will be correct, but yes, A is correct. Okay, A and C are the answers, and A is one of the correct answer because all the elements rights are greater, and then this particular root is, I mean that particular key is also greater. The count operation modifies the structure of the tree. No, it doesn't need to modify. It is just a simple function call that you can do without modification. The running time of the count is proportional to the height of the tree. Yes, because either we will going to the left or right. So that's true. Count cannot be executed correctly if x is not present. No, that's not correct, because it is not necessary x to be present in the tree, right? You just need to know how many are larger. It is not necessary that it is present. So that's why A and C are the correct answers here. Okay. Now let's solve this question. So this question is basically just similar to the Fibonacci series. Okay, Fn minus 1, Fn minus 2 they are using, but they are just using the dictionary over there. So F4 comma D, right? They're asking F4 comma D. So F4 comma D will basically first check if 4 is in the dictionary. See, writing this is same as saying in D, it is same as saying in dictionary keys, okay? So in D means like it will be only searching in the keys. Okay, this is, or you can, I think you can also write D dot keys or something, but you can directly write D also. If folder is already computed, then you directly return that using the dictionary. So basically it's like a hash table. Okay, dictionary is just like a hash table. So if 4 is already computed, so 1 2 3 4, so earlier you can say it is null 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 null. If it is already computed, you will return. Obviously it is not computed. So if n is less than equal to 1, then you directly return, I mean you directly store d of 1 will be 1. So d of 1 will be 1. So this is v, this is d of v, you can say. Okay, d of v will be 1. Now you can find out d of 2, which will be, and 0 also you can include, which will be basically summation of these two, which is 2. D of 3 will be summation of these two, earlier 2, which is 3, and this will be 5. Okay, this will be just like a Fibonacci series. You can call it, and this is called dynamic programming, which is not in directly gate DA syllabus, but this kind of algorithms can easily be asked. Okay, so you can say that finally the dictionary will be just like, okay, they are asking what it will return. The final value is 5, right? So df of 4 comma d, and then what is this d? D will be, I think, yes, 2 will be 2 and 3 will be, yes, something like this, right? So basically for 0 it will be 0, because it is returning for, I mean, if it is less than or equal to 1, it will be just n. So for 0 it will be 0, it is 1, then it will be the summation of these two will be 1, this will be 2, and then this is 3, right? So 1 1 2 3, 1 1 2 3, yes. So B is the answer, and it will return the final value also, which is dn. The final value it will return, it will print the final value also, which means 3 will be printed. So B is the correct answer, right? 3, and this is 0 1 1 2 3. Okay, so that was easy question. If you just dry run it, it will be I mean you can easily solve this question. Okay, so this was the discussion. If you have understood everything, just let me know in the comments. Thank you, everyone. So thank you for watching. I think most of you were able to understand almost all the questions. If there is any difficulty, you can just comment on the Gate overflow and then just tag me. I will be just replying. Okay, thank you.